Welcome, everyone. This is Michael Gibbs, and we're back for day two of our AWS Certified Solution Architect Associate Boot Camp for 2022. My name is Michael Gibbs. Most of you know me, and I'm the founder and CEO of Go Cloud Architects and Go Cloud Careers. And I'm just so excited to be here with you today for the second day of our free AWS Solution Architect Certification Training. And this is a complete and free AWS full course tutorial. And everything we're concerned about is getting you cloud certified, but most importantly, cloud hired. So if you just got here, let us know that you're awake, alert, and oriented by typing hashtag cloud architect. Cafe Memories, welcome. It's good to see you while we're waiting for people to join us. Ruben, so excited to have you here today. Daniel Pike, I'm ready for day two. I hope you are too. Cafe Memories, cloud hired. I love it. I love it. I love it. Adiyemi, cloud hired. Wonderful, wonderful, wonderful. I'm so happy to see you. A cloud architect. Absolutely all of you. Let me know that you're here by typing hashtag cloud architect. YouTube, we'll talk about the housekeeping. YouTube's going to notify every one of us, and we're going to all start getting here. So cloud architect. So this is what we're really excited about. We want to make sure that you all get cloud hired. So if you're looking to build your cloud architect career, let me tell you about some few things to tell you about. Let me begin with some free housekeeping of some free things that we're going to do to help get you all cloud hired. So what I'd like you to do as follows: take this class this week, participate in this class this week, ask questions, and we're going to have a ball. So what we're going to do is we're going to do approximately 20 minutes of teaching and approximately 10 minutes of questions, so we can make sure that we can make you have a real classroom-like experience, because I want you all to become the world's best solutions architects and cloud architects. Because if we train you right to be a cloud architect or a solution architect, you're going to go out there and get cloud hired. Abigail Marks, good to see you. Sandy, it's good to see you. Pat Kramer, so good to see you. So this is what we're working on. We want you to pass that AWS SAACO2. We'll get you certified as a solution architect. To that end, here's what I want you to do. I want you all to download the completely free AWS Certified Solution Architect Professional book. Thousands of people downloaded it just yesterday. We were featured in 407 media outlets about that book that we released. 407. The world's excited about this book. Download and get yours free. So make sure you do that. Tomorrow, in the housekeeping, please join us on our How to Get Your First Cloud Architect Job webinar. I get feedback from all over the world. So many people thank us for this. I will tell you how to get your first cloud architect job. We will tell you how I transitioned from a healthcare to a technology career, so you know how to do it yourself. We will tell you lots of things about what hiring managers desire. We'll make sure you're crystal clear on this cloud architect job so you can master the things to get cloud hired. We'll tell you what to put on your resume, the things that make you the hiring manager's dream hire, so they'll hire you and pay you more. Everything we do, it's all about that, getting cloud hired. So join us for this free webinar. Chris from my team will paste the link to that. And actually, Chris, maybe you can paste it at the top for a little while of this. I want everybody joining that free cloud architect webinar, because I want to make sure everybody gets cloud architect cloud hired. So that's my goal, to make everybody that wants to be a cloud architect have the best jobs anywhere in the world. So I'm super excited to talk about that today. So what are we going to be talking about today? We're going to start with computing on the AWS cloud, because what is the cloud? It's a network and a data center that's virtualized. Basically, you're renting to use somebody else's network and data center. And what's the basis of a data center? The network, the servers, the storage, the load balancers, the firewall, the IDS, IPS systems. We're going to go through with this throughout the week. As always, I will always want you to learn how to drive the car instead of learn how to drive a Honda or a Mercedes or a Toyota. So we're always going to talk about the technology first. Then after we talk about the technology first, we'll talk about the AWS proprietary solutions. By doing this, you'll be able to work on Google, Azure, Cisco's cloud, Dell's cloud, Palo Alto's cloud, or any cloud you like Oracle. It won't matter. So that's why we're going to do it in the way we're going to do it. So now we're going to begin. And when we begin, we're going to start talking about computing on the AWS platform. So let's talk about it. When we're dealing with computing in a cloud computing environment, remember, for the most part, everything is virtualized. Everything is virtualized. So Kind of keep that in the back of your mind. And because everything is virtualized, our computing is going to be in one of two types. It's either going to be in terms of virtual machines for the most part, or it's going to be on containers or serverless. Again, container type environments. So kind of look at it that way. Now, there are times when you may need to get a dedicated host, and we can talk about that. But remember, 99% of what we're talking about in the cloud is just virtualized stuff. The same stuff in the network and the data center that's been virtualized. So let's talk about that. When we're going to be dealing with any cloud environment, we're going to be talking about virtual machines. So the virtual machine could be a VMware ESXi virtual machine. It could be a compute engine instance on Google. It can be an Azure virtual machine, an Oracle virtual machine, or if you're AWS, you have your marketing people come up with really creative names, and you call a virtual machine an elastic compute cloud. Now, I find that causes all half the confusion. Half of the world doesn't even know what the EC2 instance is because they've convinced the world that it's not a virtual machine. It's a virtual machine. You size it and you spec it out the way you would any other virtual machine in any other data center, virtual or physical. Meaning, how many CPU cores do you need? How much DRAM do you need? What kind of storage do you need? Is it throughput that you need? Is it high IOPS that you need? What kind of network performance? Can you get away with 1 gig, 10 gig? Do you need 100 gig networking? Can you use software networking like a virtual network card? Or do we need high power, high performance networking where we're going to do something called PCI pass-through or single road IO virtualization or use different types of drivers for our cards? That's up to us, the architects, to know why and to know how. So kind of keep that in the back of your mind. Now, AWS has a lot of flavors for their systems and what they call their machines and families. I don't expect any of you to ever think about learning these families. I mean, I remember some that like the G instances, think of them as GPU-based workloads, and understand that the X1E stuff is typically your big, powerful stuff that you're using for when you need large amounts of DRAM, for example. But as a rule, what are you sizing? CPU, DRAM, GPU performance, network performance, and disk performance. So that's what you're going to look at regardless of what these families are. That's how you're going to know what to do, just like any other virtual machine. So when you need a system, you can go to the compute platform on Oracle, Azure, Google, AWS, and you size your virtual machines based upon what you're looking for. What are you looking for? Do you need GPU performance? Do you need CPU performance? Do you need memory performance? Do you need disk performance? That's how you determine what you're going to use based upon your requirements. How are you going to find these requirements? Well, you're going to ask the customer about their business goals, about their pain points, and you're going to bring in your team of cloud engineers to baseline the systems. And they're going to look and say, hey, these 4-core systems in the data center with 16 gigs of RAM, for example, a very small server, is 80% utilized. We need bigger. Or we've got this 32-core server that's running at 5%. So you'll know what you need to do, how to architect, how to re-architect, and do all of this stuff based exactly on the performance that you need. So when you're dealing with AWS, you can get your virtual machines on basically 3 operating system platforms. Effectively, what you're dealing with is Linux and Windows, but you can do Mac OS, and I'll tell you why and how and where. So when you're dealing with a server, 99% of everything that's going to be out there is going to be Linux and Windows. And guess what? When it comes to the internet and big web applications, it's almost exclusively Linux. So the whole cloud is built on Linux. The whole cloud runs Linux, from the control plane that orchestrates the cloud to the servers. It's all Linux. The hypervisors are Linux, so it's all Linux. So most of what you're going to be doing is setting up Linux systems, but there are times you use Windows servers, such as Microsoft Exchange and Active Directory, so those are good reasons to use Windows servers. When you deal with virtual machines in the cloud, you can make your own virtual machines. You go to your VMware ESXi server, you create your perfect virtual machine, you tune it, and you can convert it to basically an image that you can just import into AWS. Or you can go to AWS, and it's not like the data center where you've got to go to the server, install your hypervisors, your operating system, etc. You can just select the system you want. Click, 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 just like we did in the lab that we showed you guys last night. Super, super easy. Click, you can start a virtual machine. I taught an 8-year-old how to set up an AWS virtual machine in less than 5 minutes, and she was real good at it. So plain is, it's very easy to do. So when you're dealing with your virtual machines, what are you dealing with? You realize you need a virtual machine. Now you know what they're at. Now, when you can make an image of your virtual machine, like we do in the data center. Same thing, we've done it forever. You image your servers, right? You turn that into an image. Now we can make those images. So when we make those images, Amazon calls it an Amazon machine image. And basically what it needs is an instance, which means a virtual machine, and a storage volume for that instance, like an EBS volume. That's it. That's your virtual machine. So let's talk a little bit more about them and where you can get your virtual machines. So there's going to be a lot of them. So you can use the AWS virtual machines. They're pre-made and they're pre-built for a tremendous number of use cases. They're awesome. Now, what if you need real security? What if you need enterprise-grade security? Well, you're not going to be using things like WAF or the built-in cloud-native tools. You're going to be using something enterprise-grade. So you might be getting 2 Palo Alto firewalls or 2 Cisco firewalls or 2 Juniper firewalls, 2 Fortinet firewalls, 2 Palo Alto firewalls. And where are you going to get that? You're going to get it from the marketplace. Or maybe you need a load balancer that has much more capabilities than the AWS Elastic load balancers, and you want something from F5. Again, you can get that from the marketplace. Maybe you want to contend with 100,000 remote access employees coming into your systems. Guess what? You can get a VPN concentrator from the AWS Marketplace. So the AWS Marketplace has pre-built systems with databases like enterprise-grade things, pre-built load balancers, pre-built applications. So you can get something directly from AWS, or you can get a pre-built industrial-grade solution from the marketplace. And if you're on Azure or Google or Oracle, they all have marketplace solutions because big companies and big customers, they're not going to be using a lot of these cloud-native things because they need to be in multiple clouds. Single cloud is a single point of failure, no matter how many availability zones and regions they use. So the point is you're going to be using a lot of stuff from the marketplace in real life as an architect. They don't talk about it that much in these courses, but in real life, you're going to be pulling stuff from the marketplace and it's not going to be AWS things. But AWS things are great, but you need to know both. So keep that in mind. The last way you can build your Amazon machine image is you just take one of your servers in the data center and you can import it from VMware, VirtualBox, or incredible ways. So we've been all converting virtual machines from one form to another for about 15, 20 years, and this is no different. So what goes into making an image of your server? Well, you need an operating system, Linux or Unix, launch permissions, and basically a block device mapping that attaches volumes to the system. Now, I do want to say that with AWS, you actually can get a Mac OS EC2 instance or virtual machine. Absolutely, we have that. So keep that in mind. We can do an AWS virtual machine that relies on a Mac Mini. Now, nobody would consider a Mac Mini mission critical, and the reason they wouldn't, it's got a single power supply, it doesn't have error-correcting DRAM, it's got a consumer-grade CPU. So why would we use a Mac Mini as an EC2 instance? Well, maybe we've got a developer that needs to compile code on a Mac, so basically they just use a Mac Mini for 24 hours. That's the reason we'd be using Mac things in the cloud. Now, let's say you make a machine image of one of your machines in your data center, and then you move it to the cloud. What if you want to move it and you're in the US? What if you want to move it to a European region? No big deal, go ahead, do it. So we can snapshot the machine with the machine image, we can move it around. Think about disaster recovery. Let's say you've got 50 servers. You make an identical copy of each server. You store your hard drives directly in object storage. You've got a problem, you launch all your machines and all your data, and you're up and running. Now, you could get up and running even faster if you deployed the virtual machines as infrastructure as code. But the point is, if you're somebody on your DevOps team can do that. You can get up and running very quickly when you've got copies of your machines and copies of your data. So realistically speaking, when you're dealing with Amazon Linux, there's Amazon Linux and Amazon Linux 2. It's supported by AWS. That's going to look and feel a lot like Red Hat. It used the same Yum packages. It's based off of that same, Red Hat distribution, CentOS distribution, Oracle distribution, and then all the manufacturers tune it to themselves. So kind of keep that in the back of your mind. Now, when you're setting up a virtual machine, remember, it's a stock machine unless you made it yourself. So if you're going to pull an AWS virtual machine, guess what? It's going to have nothing on it. It's going to be a bare minimal install of Linux. So you can actually set these things up and they boot up or auto scale update the operating system, install your necessary packages, install your necessary dependencies, patch the operating system. And that's what I do. So if I'm going to bring in a server, when I first build the server, I'm going to upgrade it. So we can do that with a server. We can write a bootstrap script that says, yum update. If we're using a Debian distribution, we can have it come up with a sudo apt-get update and a sudo-update install. We can literally make our systems come up. We can install an Apache web server, patch them. We can do all kinds of scripts. And if it's Linux, it's basically a simple shell script. And if it's Windows, it's a PowerShell script. But in any case, we can do it. We can pre-build these systems. And guess what? The way we're doing this is no different than what we've done in the network and the data center for the last 30 years. We've been running bootstrap and automation scripts to take new Windows systems and new Linux systems. This is old technology. It's just doing the same thing. None of this is new. So when you're getting your virtual machines in AWS, what kind of options do you have? Now, granted, there's all these families, A, B, C, D, G, F, G, H, I, J, K, L, M, N, O, P. Sounds like an alphabet song. But let's get rid of all that complexity. Basically, you have three or four ways you can purchase your interested. What makes people go to the cloud is on-demand and auto-scaling. Here's the thing. In my network and data center, I've got the maximum performance in the world. Maximum performance. But I also may have the maximum cost. So in my data center, I have to build my servers for my peak capacity. So let's say we're dealing with a retail store. Peak capacity in the US is Black Friday, which is the day after Thanksgiving, when all the stores offer their big sales and people go running in droves to buy stuff. So in the data center, I build my entire website to deal with Christmas traffic, and my systems sit idle the rest of the year. What on-demand enables you to do is as following. Purchase what you need when you need it and gradually add capacity as required. So that's done via on-demand. So with an on-demand instance, you can do auto-scaling. What's great about on-demand? You're starting a new company. You have absolutely no concept of how much networking you're going to need, how much compute you're going to need, how much performance you need. You have zero knowledge whatsoever because it's a new application. Guess what? Guess what? Do the following. You use on-demand. Now, by using on-demand, your systems are going to grow and flow and do everything they're supposed to be, and it's going to be great, 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 great experience. Okay. Now, for that flexibility of not knowing what you need, you're going to pay a lot more money, because if you know what you need and you tell Amazon, I'm going to need this server for 3 years, they can give you a special price. But, if you don't know what it actually is, guess what? You're in a challenge. So that's the key. So you use on-demand until you figure it out, unless you know, in which case you go there. But once you know what your needs are, you sign a commitment with Amazon and you get something called a reserved instance. And a reserved instance is AWS, I need this virtual machine for the next year, the next 2 years or 3 years. And by doing it, they'll give you a very substantial discount. It could be 30, 40+%. Just to tell them ahead of time what it is. And why is this? Because if you commit to buying, 3 years of that service, Amazon can use your money to buy more servers and further build out their infrastructure to support a lot more customers. So it's guaranteed businesses, and businesses love for you to be stuck. So with reserved instances, you make a commitment, and because of that, they give you a better price, and it makes sense. So on demand, use what you need, but basically is most expensive. Reserve is an issue of you know what you need, you have guaranteed needs. So guess what? You use those needs and poof, you're in great, 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 great shape. So kind of keep that in the back of your mind. Now there's another kind of a reserved instance called the scheduled reserved instance. Let's say, for example, that you knew that you had work to do every Saturday and Sunday for a year. You can get something that's called the scheduled reserved instance, which basically gives you contracted pricing for as many days a week as you reserve it. So scheduled reserved instance is not going to be as cheap as reserved instances because you're not committing to use them all the time. But they're still going to be cheaper by far than just using an on-demand instance. And that's really the reason. That's a scheduled reserve because it's going to give you a discount. Now, there's a couple more ways you can actually get your servers in the cloud. There's something called the spot instance. And I want you to understand the spot instance. It's relatively dangerous to use, and there are times where it makes sense. A spot instance may be called a preemptible instance on, say, Google. And what it means is the cloud providers have all this unused capacity and they auction it off. And if the auction price is 1 penny per hour to use it, I've only got a spot instance, you pay the auction price of 1 penny per hour. Now, if somebody bids higher than the 1 penny, you get kicked out and you get shares, your computers get shut off and you lose all the data on your computers, especially if it's not on an EBS volume. So know that. So if you've got a batch job that's not critical, that can be started and stopped multiple times, spot instances are amazing. But think about it this way. You don't ever want to build your infrastructure on technology that can just collapse or be shut down by the cloud provider. So spot instances are from there, some very specific use cases. Then the next option is the option of a dedicated host. Now this is your basic data center server. Here's the reason. Very often in life, you've got an application that's tied to the MAC address of your system. Or you've got an application whose serial number requires you to plug in a USB key to the server. It happens all the time. Or you've got something that looks for a serial number of something. You may need a system that needs to tell you exactly what's going on with the physical CPU and the physical memories. And for that, you can buy a dedicated host. What is dedicated host? You're just buying your own dedicated server in the cloud, which effectively means you're buying a server like you would in your data center. So that's going to give you good performance when you need it too. So kind of keep that in your mind. So let's talk about some tenancy options for this. And then, we're probably going to take a break for a few minutes and answer some questions. So let's talk about tenancy options or where your systems can be. Most systems, if you do nothing in the cloud, are going to be what's called shared tenancy. What this means is you create your EC2 instance, your virtual machine, and this is true of all cloud providers, whether it's a Google Compute Engine thing, an Azure virtual machine, or Oracle virtual machine, or anything else. Shared tenancy is you create your virtual machine, and there could be 30 other customers sitting on that same server. You're logically separated, but shared tenancy, meaning that server has all of you. And that works fine too. Now you can buy a dedicated instance, which basically means it's a server and all your virtual machines go on that server. And that works nice and fine too. Totally. Again, something really great that we could be talking about. Or you can buy a dedicated host, which is what we're talking about, which is basically a bare metal server. When you need licensure requirements that need to attack it, that's what you're going to do. So I want to make sure that you guys are all with me on these EC2 instances. Let's make sure. We'll take about 10 minutes to answer some questions that you may have. But before we do that, if you can hit the like button, if you can subscribe, and if you hit the bell, you'll be notified of all the new things we're doing. This month, we have so many things coming to you. Free webinars, free architecture lessons, free CCNA or Certified Solution Architect Associate things, the free ebooks, and I want you not to miss on anything. So let's do this. So Chris, if you want to bring in some questions. We've got a lot of questions.
All right, sure thing. Give me just a second.
You got it. You're doing that. I'll verify one thing over here while you're looking at your messages. If using on-demand and reserved, will you be billed for the time that you're shutting off or pausing your systems? Typically not. If they're not running, you're typically not paying for them if you shut them off. But I am not the expert on AWS billing. I'm more of a systems designer, and I usually have someone from my team actually look at the billing and help me quantify the billing, where I focus on the business acumen, leadership, and the end-to-end design. But generally speaking, when your systems are not being used in a cloud provider, you're not paying for them. Meta over cloud. Do spot instances have a predefined duration? No. Basically, you tell them you basically use it until your job's done or until you get kicked off because the price went up and it was greater than what you actually previously paid for. Alok, difference between a dedicated host versus an instance. Dedicated host, physical server. You have complete control over it. You can create your virtual machines if you put a hypervisor on it, you can magically create your virtual machines in terms of CPU cores and memory. If you've got an application that needs to be installed directly on the bare metal, you can. So a dedicated host is a plain server. A dedicated instance and will give you maximum performance load. A dedicated instance is basically a server that's already got the AWS hypervisors on it. So it's no longer a bare metal server. It is now a virtualized server, and you can put a bunch of virtual machines on there. Now, Alok, when you go from a hardware server, a physical server, to an actual software-based virtual machine, you have to really understand that you're losing performance at least 10%. But when you're dealing with a dedicated host and it's a bare metal server, you're not losing any performance. You're getting that maximum performance. So with a dedicated host, if you decided you wanted 6 GPUs in there and you wanted to do PCI pass-through, with dedicated hosts, you're really in a position where you can make it exactly what you need to. So Alok, the dedicated host basically takes you back to data center kind of performance and quality in the cloud, where a dedicated instance is just a server that's pre-virtualized, and it's just, now I make 20 VMs or 30 or 40 or 50 VMs and they go in the same server. Hope I answered your question there. Chris, if you want to bring in the next one, please, by all means, hit the like, comment, and subscribe. Live Harmony, difference between IOPS and throughput. Live Harmony, we covered that extremely in detail yesterday, so please go back and see that. But I'll answer it real quickly. IOPS, or input and output operations per second, is how fast you can read and write from the disk. Read, write, how fast you can do it. Throughput is how much data you can move. So IOPS, for example, is in terms of number of operations. So let's look at it this way. If I could write to the disk 1,000,000 times per second, which I can do from an NVMe drive, the Samsung 980 Pro from Best Buy for about $100, it means I can write and read to the disk 1,000,000 times per second. That means my latency is very low. But now, Live Harmony, let's say I have to send you data. Throughput is how much data I can send at a time. So you've got 2 devices, you've got 2 vehicles next to each other. Vehicle here is a Ferrari. It can go from 0 to 60 in 2.2 seconds or whatever it is. I don't know anything about race cars. Over here, we've got a tractor trailer that you can fill with 20,000 kilos of stuff. The stuff that we're moving is the throughput. So the big diesel truck has high throughput, but it's slow. You know, you try and get it to 60, you shift it, brum, 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 smoke's coming out, brum, brum, more smoke's coming out. It may take you 15 seconds to get to 60 miles per hour on that big tractor trailer, meaning the latency is low, but the amount of stuff you can put in that trailer is great. You know, that Ferrari may go from 0 to 60 in 2 seconds. But how much stuff are you going to put in the trunk or the boot? Not much. So that's your difference. IOPS, or input and output, is latency. Throughput is how much stuff you need to move, and it's measured in megabits or gigabits per second. It is a fantastic question you asked there. Chris, if you want to bring in the next one. Spot instance is a single system that you purchase that's not guaranteed to be there if the price goes up. A spot fleet is a bunch of them. Shared tenancy just means that when you have your virtual machine, hundreds of other customers may have virtual machines on your same server. So that's all. Chris, you want to bring in the next one? Pierre. Hi, Mike. Hope you're doing great today. I hope you're doing well, Peter, as well. Is a dedicated host and a dedicated server the same thing? Or is a dedicated host mean is it doesn't have the hypervisor? Exactly. A dedicated host is based, or a dedicated server, it means that there's, or a dedicated host means there's no hypervisor. It is a physical server just like you would buy from Dell, etc., or IBM. Exactly, Pierre. Adi Kunli, is it better to shut down or terminate it? Effectively is the same thing. I generally get rid of them when I don't need them anymore. What is the unit of time you purchase a spot for? Is it per minute, per hour, per second? I don't remember. I'm an architect. I do end-to-end system design. I don't get involved in the pricing thing. I usually have somebody on my team do that for me. But I think it's per second, but I'm not sure. How long, K-Flu, how much notice will AWS give you before they shut you down? 5 minutes. which effectively is nothing. So it's like, hey, imagine a batch job that's running 48 hours straight while you're sleeping. And at 3 o'clock in the morning, you get a message that says, hey, in 5 minutes, your systems are going to be shut down. You probably won't have a chance to do anything about it. You're basically buggered out when you're using a spot instance. So spot instances can be great for batch jobs. Spot instances are only good if it's non-mission critical, not real important, and if you can tolerate to restart and lose everything. So, there's a time and a place for spot instances, but realize, your architecture should be around things that are going to work and be there. Don't build your system on a house of cards. Don't build your foundation on sand. Build it on cement. Make it strong. Spot instances are not strong. They are really, really weak. They are just extra capacity when you need it. Stay away from that stuff the rest of the time. Naga Prasad, how an account financial capacity is checked on. I'm actually not even sure I understand that question, Naga. Chris, do you have any insight onto what that might actually mean?
I do not.
I do not. Naga, I need you to ask the question a little more clearly for us to understand it. I unfortunately don't understand what you're asking, and therefore I don't understand how to answer it. So Chris, if you want to move on to the next question. Matt Hoor, for on demand, is it possible that you're not? Okay, hold on. I gotta try and read these before I read them, interpret to try and translate them a little bit. Okay, Matt Hart, if I understand you correctly, because the first sentence I don't understand, this is if you're asking if there's a disadvantage of using on demand versus reserved, yeah, the disadvantage is the cost. The advantage is the flexibility. You can purchase exactly what you need and when you need it. The disadvantage is you're going to pay a lot more because it's using it on demand. So with anything, you make a commitment, you get better prices. So, kind of keep that in the back of your mind. Live Harmony. Spot feed as many instances where it can be either. Just a spot fleet is a whole bunch of spot instances. You're making it complicated. You have one car, you have a fleet of cars. Same thing. While we're at it, if you can hit the like, subscribe, hit the bell. We've got so many things coming your way, and we don't want you missing out on any of them. So, Chris, do we have any others? We can do one more.
Yeah, so Naga just resent his.
Okay. Naga? Now, Chris, do you understand that? Because I still don't.
I would like to think that he's asking what determines the provision of the instances, maybe.
Okay, so Naga, if you're determining if you want to determine what kind of computer or virtual machine to create, you have to look at the performance requirements of the application. How many CPU cores does it need? How much DRAM does it need? What kind of disk performance does it need? What kind of network performance does it need? What kind of GPU performance does it need? So I'm not really sure that I completely understood otherwise, so I hope I actually answered that.
Yeah, and Abigail says maybe he's asking how's the price determined? Again,
well, okay, so if you're asking how the price is determined, the price is set by AWS on everything. Now, granted, you can negotiate better pricing with them, with your account manager, but it's set on everything other than a spot instance, which is bid on like eBay. You basically bid what you're willing to pay, and if there's capacity, they'll give it to you, and if there's not capacity, they won't. But if that price changes completely, it instantly has gone away. So the key is if you're going to use a spot instance and name your own price, like Priceline, when that thing gets shut down or doesn't work because you named your own price, understand that's going to happen. So if systems matter, they're going to matter. So let's get back to the content. Please hit the like button, hit the subscribe button, hit the bell. If you're here and you're having fun, type hashtag cloud architect. There's 276 people right now. I should see a couple hundred cloud architects. Hopefully we see some likes. Hopefully we see some subscribes. I want to make sure you get the free CCNA training on all the stuff we're doing. And that only happens if you're subscribers to our channel. So please make sure you're subscribed so we can go out there and we can help you get the maximum things, so we can help you build the best cloud architect career. Because that's what we're about. We're about getting cloud hired and building cloud architect careers. There's no point in doing certification training if we don't train you how to be cloud hired in the end. Marla, cloud architect. Daniel, hand of God, fantastic. Brandon Bowman, Drew, Bonaventure, Chevron, excellent. Paige, Amaranth, excellent. Pierre, loving it. Cloud architects out there. That's what we're building. We're building cloud architects. Let's get you guys all cloud hired while we're at it. Okay, so let's get into some more tech content. Now, if we're going to use virtual machines, maybe we should secure them, huh? So what options do we have? Now, when we talk about security, we're going to get into heavy enterprise-grade security. But right now, we're just talking about the simplest means to secure an EC2 instance. AWS gives you something that's the equivalent of a host-based firewall that basically enables you to protect a service or a virtual machine. And we'll spend a lot of time talking about firewalls and network ACLs and security groups, etc. But understand that AWS gives you an ability, the ability to secure your systems with the equivalent of a pre-made host-based firewall. And it's called a security group. AWS calls this a security group. Other people might call it a network security group, but here's what it is. It basically is a stateful firewall for your virtual machines. Now, granted, I put another virtual firewall on my virtual machines too, but keep that in the back of your mind. What we're doing is we're securing our virtual machines. So keep this in mind. So how do we do it? We have a security group, which basically is a host-based firewall that says, here's your virtual machine, here's your firewall, traffic wants to go in, it's either going to be denied or permitted based on policies. We're going to party with that. That's security. It helps. It's one layer of the many layers of the security layer cake. So, because firewalls block all traffic by default except what you allow in, if you want to secure your EC2 instance, what are you going to do? You're going to be allowing in the traffic. So maybe you've got a web server. What are you going to allow in? Port 80 and port 443. That's what you're going to allow in because that's your web stuff. Maybe you've got a server that only needs to be accessed via SSH. What are you going to enable? SSH, TCP port 22. Kind of keep that in the back of your mind. Now, when you're writing a security group policy, you give it the protocol and port number. Permit TCP port 179 for BGP. Permit TCP port 53. Permit UDP port 53 for DNS. So kind of keep that in the back of your mind. That's what you're really dealing with. So understand that you can put a source and a destination of the packet just like you would any firewall. So what's this thing going to look like? It looks kind of like this. You've got this environment, and in your environment, you've got your, we're calling them instances to try and keep it in line with what AWS likes to call them. They're your virtual machines. Your virtual machines have a little firewall. Keep the traffic out of the virtual machine with a security group. That's all it is. That's all it is. Now, virtual machines, we want them to talk to each other, right? Meaning, if we had a virtual machine and it had no network card, it'd be air-gapped. It would be useless. We'd have a server. If you wanted to access the server, you couldn't. No network, no nothing. So think Facebook outage, no network, they were down. Think the AWS impaired network, no network, they were down. So, you know, if the network's gone, everything's gone. So what does the device need? It needs to be plugged into the network. It needs to have a route to the network. It needs to have a default route off the network or else a routing table. And it needs a unique IP address. I want to send a mail to Chris. I need to know his address. I want to call Leo in Brazil. I need to know his address. I see Brandon and Abigail and some other of my amazing students in this call. I want to call them. I need their address. If I want to send a message to their computer, I need their IP address. If I want to call Abigail, I need her phone number. If I want to call Brandon, who's an incredible cloud security architect, I need his phone number. By having that, I can reach him. So computers need an IP address. So how do you get the IP address? The good news is you can put multiple network cards in there. Maybe you've got a dual home server that needs to be on multiple subnets. You can have multiple cards. What does AWS call a network card? They call it an elastic network interface because they have to stick the word elastic in front of everything. But guess what? It's going back to the following. We are going back to putting an IP address on it. So every interface on a system will require a unique IP address and a subnet. 4 network interfaces on your card, in your server, they're all going to be on 4 subnets unless you're bundling together in a link aggregation group, but that's something beyond what we're talking about right now. Each instance on another subnet. If you need your server to be reachable by the internet, it must have a public IP address or be in an environment where we're doing that in some way, shape, or form, or some routing in between instances. Devices that need to be reachable, like web servers, either need to have a public IP address, or the device that looks like the web server, which is a load balancer, must have a public IP address. You can get a public IP address from AWS. For these systems, they call it an elastic IP address, and we'll talk about much, much, much more than that in the VPC sections. So we can use private addresses, which give us security and protection from the internet, and they don't cost anything, or we can do this. Now, when we launch an instance, we actually get an IPv6 address. Now, all IPv6 addresses are globally routable. There's no reason to use NAT on them. The reason we use NAT is, the IP address space is a 32-bit address space. So you do 2 to the 32nd power, and you can see we ran out of addresses. There's a couple billion there, which is a lot, but not enough. Now, IPv6 is, instead of a binary, meaning 2-bit, it's hexadecimal, meaning 16-bit, 0 through F. And it's 128 bits long, so it's going to be 16 to the 128th power. So now you can see 2 to the 32nd versus 16 to the 128. Wow, IPv6 is really good. And it's going to last us for a long time. Now, if we want don't want an IPv6 address, we can do it. We just disable it. But remember, every interface is going to require a VPC address unique space because they're all going to be on different subjects. Kind of keep that in the back of your mind. I'm a visual person, so sometimes I'll use terms like see, or, if an auditory person, they'll say things like, I hear you. So, kind of keep that in the back of your mind as we cover some of these things. So how do we access and manage our EC2 instances? Well, how would you manage any system? Well, you can use the console port, the management console. We can SSH or secure shell into the machines, which is what we use for Linux. And if you're using Windows servers, and you're not going to be using many Windows servers, but if you are, you can use that remote desktop protocol, which is kind of like a screen sharing, like a VNC, but it's built into Windows. And you can also do some management via the software development kit, which basically means the API. So let's go back here. So in summary, we talked about EC2 instances. We talked about machine instances. We talked about purchasing options, tenancy options, securing EC2 instances, providing IP addresses, and assessing and managing the instances. Now, we're going to get into some databases, and we're going to talk a lot about database technology. So if we desire, for approximately 2 minutes, 3 minutes, we can ask any more EC2 questions, about 3 to 4 minutes, and then we're going to go straight over to the networking, to the database piece. Is there any questions, Chris, that popped in the last 2 or 3 minutes that we need to address? Otherwise, let's go back and let's move on to the next thing, because we've got a lot to cover, but I don't want to leave anybody left behind.
I think there was a question that came in towards the beginning of that. Let me double check it and make sure. And I think Brandon may have actually answered it, so give me just a second.
No, actually, we should address VNHG with regards to stateless and stateful.
That's that's one of the questions.
That's a really important question.
Yeah, that's one of them. But there was one right when you started asking for cloud hireds and cloud architects. Okay, well, we'll answer VNHGs while I find that one. Is that the one? The security group is stateless. That
yeah.
question?
Well,
okay.
So VNHG, the security group is stateful. The network access list is stateful. Firewalls are stateful. Here's what this means, a very simple thing. Here's what stateless means. If you run across the street from your house and run back to your house, if you don't tell anybody and nobody's watching you, that's stateless. Now, if you decided to have your wife stand at the door and then you walked out and told you left and told you to come back in 1 minute and she saw you 1 minute later and let you back in the door, that would be stateful. So here's what happens. A network ACL is stateless, meaning it just verifies source destination protocol port. Either deny or allow through. Now it's allowed through. Now what happens if it's stateless? Nobody knows that it was allowed through. So you have to permit it on the way back. So let's talk about firewalls because they're stateful. This device, let's pretend this device over here is a firewall. Actually, I have a firewall that looks just like it, but this case happens to be a switch. So let's say I've got this firewall, and here's what it's going to look like. Here's the firewall, pretend my firewall is a hand. I decide that I want to go to www.gocloudcareers.com. I initiate a connection to gocloudcareers.com. My hand is the firewall. My traffic goes through the firewall. My internal traffic goes through the firewall. The firewall says, Mike Gibbs is going to www.gocloudcareers.com. Then GoCloud Careers answers my question, VNHG, and it goes back to the firewall, and the firewall says, I'm going to allow you through because you're coming to Mike Gibbs, and Mike Gibbs already asked you a question, so your traffic is allowed back. How does the firewall know to allow that out? The firewall watches. The firewall tracks. So firewalls by default block all incoming traffic. But if you're behind the firewall, they let you go out and they let your traffic come back. What stateful means is they're watching the connection. They're tracking the connection. So the next time you hear stateful versus stateless, think about it this way. If you wanted to leave your house, let's say you had a guest in your house and they left and they don't have a key, they're not coming back in. But if you know this guest and you said, guest, you're leaving my house, on the way out the door, pick up the key. And when you come back, turn the key on the way in. And when you turn it in, check off that you returned the key. That's stateful. So stateful is really just keeping track of what's going on. And because it's keeping track of what's going on, it knows to allow you to return traffic back. So firewalls are all stateful. Security groups are stateful. Network access lists are stateless. Now, that's why when you apply an access list, you have to apply it in both directions, because nothing's tracking the state of who initiated the connection. So a security group is stateful. So you only have to let it go on the way in. Here's why. If you're saying allow port 443 or HTTPS traffic into the server, when the server responds, it's stateful. So it already knows to send the traffic back. Now, if it was stateless, it would go through, but it wouldn't be allowed to come back. That's the difference between stateful and stateless.
All right, so I didn't find the question, but Ria reposted it for me. So here we go.
It's NeoS Horror. What is a Nitro-based EC2 instance? Okay. Get rid of all the Nitro nonsense. Get rid of all the fancy name nonsense. When you do virtualization, you take a bare metal server, you install a hypervisor, and that hypervisor is what manages the memory. Common hypervisors include VMware ESXi. Nutanix has their hypervisors. KVM is a good hypervisor. QEMU is a hypervisor. Citrix makes a Xen hypervisor. And AWS made their own hypervisor, and they called it Nitro. That's all it is. It's the name that they branded their hypervisor. Kumar, let me try and read this first. Kumar, I'm not completely sure of the question you asked. All security groups block everything by default when you create them your own, and they only allow in. Now, if you use the default one, Kumar, what comes with the cloud is when you use the default thing, there's absolutely zero security. So if you just use the default one and the default security groups, expect to be hacked that day or minutes from the second you launch their interest in a public subnet, you'll be hacked. So the default one permits everything. Why is the default thing so flexible and so open? Because they want you to know it's just going to work no matter what you do, and security can break it. So they assume that a lot of these things that are default don't have a lot of security. But the default policy of a security group that you create is to block everything until you put it in. So when you make a custom one, you have to do it. What's the difference between machine instances and EC2 instances? Absolutely nothing, John. AWS made up a made-up term and called it EC2. The rest of everybody else calls it a virtual machine. And the rest of us know it is a virtual machine. I'm not a big fan of obfuscation, where you take something very simple and you make it sound complicated. And an EC2 instance, in my mind, is the most worthless term for the word virtual machine. It's the same virtual machine that has been going on for the last 2 decades. Nothing's changed at all. In fact, IBM invented virtualization in the late 1970s. So what we're dealing with is actually 50-year-old technology. We just named it Nitro, and they called it, instead of making it sound like a virtual machine, which is really easy to everybody to understand, it doesn't sound cool. It doesn't sound passionate. So why did drug companies take a drug like atorvastatin and rename it Lipitor? Because it sounds cool. Well, marketing people came up with the term elastic compute cloud instance. What really is, it's just a virtual machine. Know it is a virtual machine. You know what to do on Azure, Oracle, Google, Dell, Palo Alto, or any of the amazing thousands of clouds that are out there, and you'll be great. In IPv6, do we need to classify private and public subnets? There really isn't the concept of private and public subnets in IPv6, but you can subnet IPv6. Every address is globally routable. Kumar, does stateful and stateless meaning different when we talk in terms of networking or database services? No. All stateful means tracking. Stateless means non-tracking. So it's the same thing in networking, security, databases, etc. Good question. Saying, is it correct to say when we talk about stateful, it is only applicable to specific connection requests? If we enable all outgoing traffic, doesn't it mean all incoming traffic is also allowed? If it's stateless, you can allow all outgoing traffic and none of the incoming traffic will be allowed in because they won't keep track of the state. If it's stateful, all your traffic that was allowed out will be allowed to return back because it keeps straight. It's like letting someone leave your house and return. If you go to Disney World, for example, when you leave, they stamp your hand and then you can come back in because it's stateful. You got a stamp for the day and they know you were there. Whereas if you just tried to walk in and you didn't have that stamp on your hand or your ticket stub, they wouldn't let you back in because there'd be no state, nothing to track you. That's a very good question. Babita, how do we include IPv6 if an older system is using IPv4? Well, you're going to get an IPv6 address no matter what, unless you disable it. And then you just put your IPv6 subnets in your routers and your routing tables, and poof, everything's going to work. Great question. Can you have an IPv6 only subnet, Nathan Richards? There's thousands of IPv6 only subnets. Pretty much every phone is on its own IPv6 there. So you may have, 2 or 50, 150 or 500 phones in a subnet. There's how many billion phones in the world, and they're all in IPv6 only subnets for the most part. Bonaventure, if somebody outbids you for your spot instances and they finish, do you have to rebid at your price to get the instance back? Most likely, you'll never be able to rebid in time, and your systems are going to be shut down and all your work is going to be lost. Now, if you're just lucky enough to be using the spot instance and you happen to get that 5-minute notification, and from that 5-minute notification are received, need to be by a computer, and you can get the approval from your management team that it's okay to basically bid more, then yes. But the chances of that actually happening inside of 5 minutes are close to 0. So spot instances are the riskiest thing you can do when it comes to computing. If you use them, know that there's a good chance that your system will be totally useless, totally be shut down, and you'll have to restart again. Now, it's very cheap. And when it comes to performance pricing, your best reality is going to be a combination of reserved instances, on-demand, and spot instances. But realize those spot instances could potentially be so dangerous because they're preemptible or they can be shut down. Don't use them for anything that matters. Alok, no, the security groups work at many different levels. We've got security groups for load balancers, EC2 instances. Same stateful firewall kind of functionality, though. Chris, did we miss any more? Jordan, what exactly do network interfaces do again? Network interfaces are network cards. If your computer doesn't have a network card, you can't plug it into the network. That's what a network interface is. So a server needs a network card. It could be a physical card that you plug a gigabit or a 10 gigabit or 100 gigabit Ethernet connection to. It could be a fiber optic card or a virtual machine. It can be a virtual network card. But the way systems have video cards and they have hard drives, they have network cards that actually bring you on the network. So let's go back to the content. Let me just remind you of 3 things. If you're having a good time, please hit the like, comment, subscribe, and hit the bell. Please make sure you get your completely free AWS Certified Solution Architect Professional Exam Guide. Please subscribe and hit the bell to be notified of all things. And if we're having fun, hashtag Cloud Architect right in there. There's a couple hundred of you. I love seeing the words Cloud Architect all over the screen. Makes me happy. I'm excited about architecture. I've been an architect for 25 years and there's no better career. So hashtag Cloud Architect. And let's get back to the party and we'll start talking about databases as soon as I see a couple hundred cloud architects. Okay, I see a bunch of cloud architects coming in. I'm getting happy, getting excited. The reason we're doing this is we're building people's cloud architect careers. I want you all getting cloud architect jobs. I want every last one of you cloud hired. And I want you to build the most amazing cloud architect career, solution architect career, enterprise architect career, any kind of architecture career that you want to build to be a future business and technology leader. I want you all to have it. So I'm real excited. I see all these cloud architects. It makes me happy. So that's why we do it, to get everybody cloud hired. So let's talk about databases. Databases are one of my favorite things. Let's begin with, what is a database? A database is basically a type of server that allows for the storage of large amounts of information. Now, what's so special about the database is it can facilitate the sorting, the calculating, the reporting and information sharing. So it's not just data. It enables us to analyze the data, to query the data, to do stuff with the data. In fact, databases are so important that they're almost critical to every organization. They're considered mission critical business systems. I know of no major business that doesn't use a database. And in fact, I don't know if I've known any major business that hasn't used a database in the last 20 years. They're so valuable for businesses to get information, to calculate, report, share it, and make better business decisions. Why do we collect data? To make better business decisions. Why do organizations call cloud architects and ask us to do our job? Organizations hate technology. They love the cloud architect for the following reason. We solve their business problems with this weird technology stuff that they don't understand how it works. That's why they like us. So when we're going to be dealing with databases, and we're going to be dealing on the cloud, you know what kind of databases we're going to have? The same kind that we have in the data center. We're going to have relational databases. We're going to have no SQL databases. And we're going to have a data warehousing database. And we'll even talk a little bit about data lakes, just so you know what they are, because they're very important concepts. So the most common databases that you'll interact with are relational databases. Now, relational databases are very good in that they provide storage and information of variables that are related to each other. So your data is related to each other. That's why we're using relational databases. So when you purchase something and it goes straight to the Oracle relational database, they know what your name is, what you paid, etc., etc. So let's look, realistically speaking, at what we're talking about. We've got the data and we're going to use it. So what's it going to look like? It's going to look like columns and rows. We're going to have these relational databases, and it's going to be structured information. We've got an order, a customer identifier, an email address. Why do organizations use relational databases? Why? What's the point? Note the relationship between the variables here. See? You can see what's related. Now, if I know that this person paid for X price, and at X price, I sold $1 million, but if I raise the price from X price plus $1 and I only sold 100,000, I got to drop my price as a company to be more maximally profitable in most cases. And I know that by getting this intelligence. I get this intelligence from my databases. It provides trackable records. Now, if I just took all this data and dumped it all in a hard drive, and I had a million files, it'd be really hard to extract that information out of the files because we need something that's searchable, queryable. That's why organizations use databases. Now let's talk about some things about databases, specifically relational databases. Relational databases adhere to something called an atomic model, specifically the ACID model. And what does that mean? They are atomic. And what does that mean? The transactions are all or nothing, meaning I wrote to the database or I didn't. There's no halfsies. Now, the next thing is consistent. The second I write to that Oracle database or that MySQL database or any of these relational databases, guess what? It's there. And everybody that reads it, if they read it a millisecond later, a nanosecond later, everybody gets the same answer, meaning consistent. So atomic, it's either there or not there. It's consistent. The second I write it, everybody gets fresh data. Now, by doing that, by making it immediately consistent, guess what? It's going to affect the scalability, but understand that. The next key thing to remember is isolated. So if Mike Gibbs buys a new cat tree for Cindy the cat, my beautiful cat, I bought her this big, beautiful cat tree. The thing took up an entire room. It was like the Cadillac and Mercedes of all cat trees. I took my cat's tree out. The cat looked at the new tree and she left the house. She didn't like it because she's a cat and she didn't like it. But that's what the key is. The good news, I kept her old cat tree just in case she didn't like the brand new fancy Cadillac cat tree. I kept it isolated. So she came in there, she looked at the new cat tree. She was like, no, thank you, Daddy. She ran out of the house. I let her back in the house. I put some toys in her new cat tree. She said, no, thank you. Guess what I did? I removed that cat tree out. I brought the old cat tree in. I isolated the two. She's back sitting in her old cat tree. So relational databases adhere to this atomic model. They're atomic, all or nothing, isolated. The cat tree in one room doesn't affect the cat tree in another room. Consistent. The second I purchased the cat tree for $500, guess what? It's in that database and that employer knows about it. Now, the last thing is durable. When we're dealing with databases, we're talking about something called durability of our data. And what does that actually mean, durable? It means the data is not lost. So, atomic, it's there or it's not there. Consistent, the secondly I put it there, it's there. Isolated, one thing doesn't affect something else. And durable means once it's there, it's not going anywhere. So now you can see why organizations love relational databases. Huge, huge, huge mission critical business application. So keep that in the back of your mind. Now, when you're dealing with relational databases in the cloud, you're going to have many options. We're going to talk about these options, but we're realistically going to be talking about things that matter. So when you build a database, you can use the stock Amazon ones, which you could, or you could bring your own virtual machines. You can take a bare metal host, you can install your own MongoDB, you can install your own Apache Cassandras for NoSQL databases, you can install your own Oracle databases, and I have customers that do it every single day. We're going to talk about several databases. We're going to begin with the Amazon branded Aurora, and we're going to give you all the reasons and warnings why that may or may not be right for your customers. Then we'll talk about the other databases that are supported on this platform. And realize again, you can take any virtual machine and install any database that you want. And if you're dealing with the multi-cloud architecture, you're going to do just that. You're going to build your same environment across 3 clouds. But we're going to start with the databases we'll talk about we'll talk about Amazon Aurora, MariaDB, Microsoft SQL Server, MySQL. We'll talk about Oracle databases, and we'll talk about Postgres briefly. So we're first going to start with the Amazon branded database. This is Amazon Aurora. And from a performance and functionality perspective, this is a very high performance, excellent, fully managed relational database. It's MySQL compatible, it's Postgres compatible, it's high performance, and it scales well. And actually, the reality is it's about 5 times faster than MySQL and about 3 times faster than Postgres. So it gives you some of the features and functionalities that you would get out of an enterprise database like an Oracle, while giving you low pricing like a MySQL database. So Aurora is designed for enterprise applications and software as a service applications. Here's why, if you're like me, you'll probably never use Aurora in your career. Aurora is Amazon proprietary, and Aurora is serverless. So if you're one of the 3% of the customers that uses a single cloud, Aurora is good. Now understand, because it's serverless, once you go to Aurora, it requires you to recode your applications. And if you try and leave the AWS cloud, it's expensive because you built them, you are vendor locked in like you can't possibly imagine by using Aurora. So if you want to do, if you're concerned about vendor lock-in and you want bargaining power and pricing strategy, Aurora is not an option for you. If you want to be connected to Azure and Google Cloud because you want high performance, high availability, you should not consider Aurora. You should throw that on the trash and think about something that you could use across all clouds, like an Oracle database that you're going to build yourself, that you're going to replicate across the clouds. So understand, there's what you're going to do for a certification exam. For the certification exam, this is the bestest, fastest relational database you can think of. It's an AWS exam and it's an AWS product. Is this a good database? This is an excellent database. Excellent database. But when you go this way, when you go this serverless environment, when you go this fully managed, you may have to spend millions of dollars recoding your applications to work on the cloud, and then millions of dollars to get off of the cloud if they raise your rate at the end of the 6 months. So if you want to do something with multiple clouds, you're going to run the same Oracle database across multiple clouds, the same SQL database, and none of this is going to ever be an option for you. So I've never used this. I will never use this. It's not part of anything that I would ever do, because I don't design architectures on a single cloud, because if they get a network problem, a control plane problem, or a hacking event, our customers are out of business until the systems come up. And we saw how Facebook lost about $8 billion in one day due to outages. We don't like to leave all our eggs in one basket. It is poor architectural design. It is a recipe for disasters. And that's why we're doing it. And that's why we're talking about why, the advantages, the strengths, and the weaknesses, because you can't design what you don't understand. And your customers are not going to love being locked into this. So when I speak to CEOs, they're like, Mike, I don't want to be held hostage. If the provider raises my rate like a cable company, I want to get out there. If the provider doesn't like me, I want to get out of there. I want bargaining power. So if you want bargaining power, you can't use any of these things. So just keep that in the back of your mind. But it is a great database. Now you can use MySQL. MySQL, old school database. Oracle now owns it. It's open source, it's popular, it's free. It is an exceptionally good database. It's not the most scalable thing. It's not like Oracle. It has less functionality, but it works on all cloud providers. So it is a great option for smaller to mid-sized web applications. Postgres, very nice relational database, much more scalable, much faster. You can use it on all your cloud providers. So this is, again, a fantastic option. You can install it on a virtual machine, whether that be an EC2 instance, a compute engine on Google, or Azure virtual machine, an Oracle virtual machine, and this is a rock solid database, relational database, just like MariaDB. MariaDB is another relational database that's going to look and feel a lot like MySQL because it was made by the people that made MySQL, but it's got extra features and functionality, and it's designed for enterprise. It's an excellent database. Again, one you can use on all the cloud providers. See, there's lots of options that don't lock you into a cloud provider. So don't use those options that make you held hostage. Don't handcuff yourself to anything. So what's next? Microsoft SQL databases. You can use all of them. So, you've got SQL Server 2008, 2012, 2014. I'm sure they use the newer version right now, since it was one slide that we didn't have a chance to update. And why are we using this? Users that have Windows workloads use Microsoft SQL databases. Most users don't have Windows workloads for anything other than Active Directory for authentication, and they use Windows-based workloads for Exchange, for email and calendaring. But some organizations use them, so keep that in mind. There's 4 versions: Express, Web, Standard, and Enterprise, and you can make any of these things work on the AWS. And guess what? You can make them work on other cloud providers too. Again, industrial grade. Keeps us out of vendor lock-in. Never lock yourself in. I mean, would you jump out of a plane with one parachute and not 2? Of course you wouldn't. People always have a primary parachute and a backup parachute. You're going to send a person into battle, you give them a primary weapon and a backup. Of course you do. You're designing an architecture, you use 2 clouds. It's just common sense. You put all of your eggs in one basket and your basket gets stolen and you're lost. So Oracle databases is going to be another one we use all the time. Why? Extremely expensive feature set and functionality. And when it breaks, you can call somebody. There's actual support. So Oracle is everywhere, everywhere. So the Oracle databases are maintained and licensed and managed by Oracle if you buy your own license. Now, you could use the AWS license as well, and that's an option that you can do, but you can buy your own. Typically, there's a standard, there's an enterprise, there's a standard one, et cetera, et cetera. Each version of these databases has different levels of performance, flexibility, and scalability, and these are exceptional databases, and they're used everywhere. Now, what kind of licensing options do you have for your Oracle databases in the AWS? Well, you've got the license included, which is basically you're using the AWS license. And this gives you limited options, Standard Edition 1 and Standard Edition 2. Or, better yet, have your own license. And then you can use Standard, Enterprise, Standard Edition 1, 2. But guess what? You can now run it across all your clouds. So get your own license. Never lock yourself into a single cloud provider. Never lock yourself into a single WAN provider. Never lock yourself into anything. If you're going to go do a 10,000-mile drive, bring spare money with you and a spare set of keys, maybe some water and a spare tire, maybe even a special gas tank in there, extra backup. Give yourself flexibility. Don't lock yourself in. Don't make yourself a prisoner intentionally. And all these proprietary things effectively turn you into a prisoner. So we talked about relational databases. Chris, how long did we cover relational databases? Before I go into NoSQL?
About 15 minutes.
Okay. Were there a lot of questions that came on relational before we go to NoSQL, or should I go straight to SQL? You're monitoring the questions and comments.
There was actually more questions about NoSQL before we even got to databases. So
are they on SQL or NoSQL?
NoSQL.
Okay, so if all these questions are on NoSQL databases, we're going to keep going until we reach the end and do the database questions. If there were questions related to relational databases, Chris, I want to stop and answer questions.
Let me do a quick scan just to make sure. There's a data warehouse, data lake. We haven't gotten to that yet. Yeah, NoSQL. Yeah. Sorry, just doing a quick scan just to make sure we don't.
Sounds great. I just want to make sure we give everybody the best experience.
And then we had people asking how to keep Facebook up.
Learn BGP and networking.
All right, so let's move on to NoSQL.
Okay, let's go to NoSQL databases and then we'll come back. So, NoSQL databases. Not new, very old. I think IBM was one of the inventors about 30 or 40 years ago. NoSQL databases stand for not only Structured Query Language, or SQL. Now, here's the reason we love, NoSQL databases. They allow for extraordinary flexibility in the schema structure. They work with structured data and unstructured data. And since the structure is flexible, a NoSQL database can scale much greater. Now, we will talk about database scaling, database optimizations, database backups, and all read replicas, caching, and killing. It's coming. But we want to define our databases first and give you knowing what they are and the advantages and disadvantages of each before we start to talk about tuning them. So keep that in mind, that your NoSQL databases means not only SQL, and they allow for extreme scalability and flexibility in the schema. And it's that flexibility that allows it to scale so much. So what we're dealing with is something called a key value pair. And what that really looks like, for example, is you kind of basically have a key and a value. And that's how you're identifying things that are going on with this database. But realistically, what are we speaking about? What are we talking about? It's the flexible schema that we're talking about. See, NoSQL databases, they're not bound to the same table and columns. So we have some flexibility. They can work with less structured data and they scale. So that's why we're using it. Now, remember, AWS has their own brand of NoSQL database called DynamoDB, and we'll talk about it. Guess what? DynamoDB is another database that I will never use in my entire life for this same reason, and we'll get heavily into that. DynamoDB is serverless, vendor proprietary, which means I got to spend millions of dollars to recode my applications to work on DynamoDB. And if AWS goes down, we're down. Since I want to use a high availability, high performance environment, I'm going to be in Google, Azure, AWS. I'm going to be in at least 2 clouds. And again, DynamoDB becomes not a feasible option with multiple clouds. So for me, DynamoDB is another thing that I'm going to throw away. Yes, it's a great database, but it locks me into a cloud provider, which means I can't leave. I don't ever want to be in prison unless I commit a crime. I don't want to go to prison. Don't handcuff me for no reason. DynamoDB handcuffs you to AWS. And if they raise your prices by 40%, guess what? You can't leave. You're going to be spending millions of dollars to get out of there. So there's that. Now, if you want to use a cloud, what are we going to really do? We need systems that work across multiple clouds. So what is that? Apache Cassandra is a phenomenal NoSQL database that's designed to run on commodity servers. What else is amazing? MongoDB. And basically, your big data architects will help you determine what you need. Is it all write stuff or is it all read stuff? Is it 50-50? And that will help you determine what kind of database to use. Your read and your write information. That's where it's coming from, based upon your application requirements. Don't lock yourself in. Don't get handcuffed. Yes, for the exam, DynamoDB is going to be the answer to 1,000,001 questions. But in real architecture, unless you're dealing with, say, a Netflix, that it makes total sense to use a single cloud, negotiate the living daylights out of it, and be so big that a cloud provider couldn't afford to raise your rates without you leaving because the press release would be too damaging. Don't lock yourself into this. Unless you're big like Netflix, this kind of stuff reduces your bargaining power. So keep that in your mind. What's good? We'll talk about what's good about it too, but just keep that in your mind. So when we talk about DynamoDB, again, means fully managed by AWS. That means loss of control. It's highly available. Yes, it's good. It's a great database. It's serverless, which means they manage the servers, the OS, and the security, which means you have no idea what's going on. I don't like other people taking control of my things. And DynamoDB stores information on high-performance, dense SSD storage. So it's relatively good. What are they telling us with regards to DynamoDB? Low millisecond latency, not bad. And you can use a DynamoDB accelerator. What is that? It's caching. That's it. It's an in-memory cache. And then we can get to sub-millisecond. And that's where we're starting to get to decent performance. DynamoDB is a great database, and it will encrypt all data by default. And it can be backed up with little or no impact on performance. Again, great database. So it's not that I don't love this database. I don't like being handcuffed. Don't make me a prisoner. So that's why I wouldn't use it. You can set it up for global cross-region replication. Now, we're going to cover this in some depth here. And the reason we are going to talk about it a little bit, is, at least for a few minutes, is remember, this is their Amazon proprietary branded. We want everybody to use this. Because if you use this, you're not leaving Amazon. You're stuck. So it's kind of like the Eagles song. You can check out anytime. You can check in anytime you want. You can never leave, the Hotel California song. So I view these serverless proprietary databases as the Hotel California. You can check in anytime you want, but you can never leave, or it becomes really hard to leave. So kind of keep that in mind. So how do we do this? The DynamoDB, of course, is going to use name value powers. Why? It's an NoSQL database. We can set it up with secondary indexes, which allows applications to have access to different query patterns. We can make a second index that's going to be local or global. Basically, what happens when we create secondary indexes and we're partitioning in the databases, it makes it scale. So we can create secondary indexes with the same partition key as the base table. We can create global indexes that span across database partitions. And the only limitation on sizing, at least with DynamoDB, is you can't have a key that exceeds 10 gigabytes. So, it's pretty robust. Again, I love the database. And if I could put it on something and leave and not be like the Hotel of California, you can check out anytime you like, but you can never leave. I would use this for everything. But I do multi-clouds and I don't get locked in. And I don't advise my customers to be locked in, because if I did, I'm not an architect. I'm not a solution provider. I'm a hurtful person. I am hurting my customer by locking them in. So that's not the kind of architect I want to be. I want my customers to say, Mike, you made us millions and billions. You did this for us. So we don't make our customers prisoners. At least I don't. And I don't recommend to do it. So DynamoDB follows the base model, meaning it's eventually consistent. So we talked about atomic things where it's all or nothing. And the second you read it, everybody sees no. DynamoDB is eventually consistent. That means if I write to something and you guys receive it a millisecond later, you may get the old data. but 3 or 5 seconds later, you'll get the new fresh data. Just that, just being soft as opposed to hard, that improves our scalability incredibly, because just that changes the same. Now, we can configure DynamoDB to use strongly consistent reads like a relational database. Means immediately after a write is readable. Guess what? What do you think happens? The second you do that, you lose a lot of the scalability. So kind of keep this thing, make sure that what you're dealing with, make sure that you're using what's right. If it makes sense to be an atomic, maybe you need to use a relational database for transactional workloads. But if you need flexibility and schema, you need to track state of video game players. Or if you need to figure out what state is of people watching a movie, you need a NoSQL database. DynamoDB can do it, but I don't like to be handcuffed to a cloud provider. Cloud providers will give you really good rates for the first year, and after the first year, they're going to raise your rates. Now, if you're starting a new business, this could be the greatest thing ever, because when you're starting the new business, you have no money. They give you preferred rates. You take advantage of it for a year. You grow your business. A year later, you can have enough money to pay for the exorbitant fees from the fee raises they give you. Great. But if the business doesn't grow, you're stuck. And when you're dealing with an established business, I don't like trapping people in. So kind of keep that in the back of your mind. Now, what's good about these serverless environments? There's no servers to think about, which means less maintenance, which means your cloud architects can be much cheaper people. You don't need as good a people if everything's serverless and pre-managed. So you can pay those people half because you don't need people that are that good. So once you go to some of these serverless things, again, they require less sophisticated people, which again reduces your career options. But I'm always in what's best for the customer, even if it reduces my career options. So I don't like people getting stuck. Now, when you're dealing with DynamoDB, what we're talking about is you provision your capacity ahead of time. So you determine your read-write performance, because if you don't do it, it's not going to be there. Now, there is an auto-scaling option. It's changed over time. It used to scale up, but not back. I believe they've changed it to where it scales back down. And there's a new ability that just came out that was just announced to create infrequent access tables. So if you wanted to create a database in DynamoDB and you had data that wasn't going to be accessed so often, you can use an infrequent access table, which is going to give you lower costs for infrequently accessed data. But remember, it's about 25% to fee to save or receive your data. So you're paying less for it, but you're going to pay to use it. And that's going to be your data rates are going to be priced upon throughput, and on-demand capacity is available with a higher cost of fixed capacity. Okay, so let's now talk about Amazon branded use cases, because they make an exam and we want to prepare you for the exam to be successful. Amazon will tell you that when unlimited scalability or near unlimited scalability is required, use DynamoDB. But again, you could use MongoDB for the same reason, or you could also use Apache Cassandra. When extremely low latency is required, again, DynamoDB is good, but you could do just as good with MongoDB or Apache Cassandra. When you've got a large number of IoT devices, this is great because it's an NoSQL database. Again, Apache Cassandra, MongoDB would do the same thing. What about things where you've got to store gaming applications, player state, leaderboards, game player data? That NoSQL database, DynamoDB, MongoDB, Apache Cassandra. Financial institutions scaling millions of transactions. Again, NoSQL, DynamoDB, Apache Cassandra, MongoDB. E-commerce, shopping carts, inventory tracking. So this is what we're really talking about with NoSQL databases. The AWS branded one is DynamoDB, but guess what? You're probably in your career going to be using MongoDB or Apache Cassandra, and that's going to be based upon your read-write load, and your big data based architects are going to guide you for that based upon that. So kind of keep that in the back of your mind. Now, before we really talk about all this database stuff and database optimizations, which is going to be a very heavy topic, and we're going to have a lot of fun with that. And if you guys want, we'll even architect them out too, because I want you guys to really get databases, because they're so important. And I'm not Mr. Database. My world's networking, but the point is the databases are so critical. I want to make sure you know them. So let's talk about this. Let's talk about data warehousing databases. So what is a data warehouse? It's where an organization stores vast amounts of information. It's called the data warehouse. Why are they doing it? So they can query this information to make better business decisions. Think about it this way. The more information you have, the better decisions you make. So data warehousing are designed to perform analysis of large amounts of data. We use them with business intelligence tools to visualize them and look at it. What we're doing is we're looking to store the data. We're looking for tools to see what the data means, prep the data, load the data. So that's what we're talking about with data warehouses. The Amazon branded warehouse is Redshift. But again, Redshift, multi-cloud environment, you probably won't be using it because, again, it's proprietary. So what we're trying to deal with is anytime we're trying to deal with, high availability, high performance systems, any of the named services from the cloud providers become unusable. So that's the whole point of what we're talking about and why we're talking about architecture versus certification. Your customers will demand open standards. Your customers will demand it. Cisco did it too. They used to have a routing protocol called EIGRP. Once you're on EIGRP, you'd have to do route redistribution to be able to use something else, and customers wouldn't leave Cisco because of it. I worked for Cisco. Cisco's the best tech company in the world. Always was, always will be. I never used EIGRP. Why? I dealt with big banks. Big banks said to me, Mike, I love you. You're Cisco. You're awesome. But I'm never going to let you handcuff me to your stuff. Because when it comes to negotiating the price next time, when you're using OSPF, I can use you or Juniper and you're going to work together. I will never, ever let you use your EIGRP. Now, I was like, that's fine because I don't use EIGRP either. And they go, huh? And I'd say, I use what's best for my customers, which is always open standards. I recommend open standards with our products and everybody else's products. And that way you can always choose what's in your best interest at the time. Now, people keep coming back to me, even if I don't have the best product. And here's the reason why. They trust so much and they know that I would never do anything that wouldn't be best for them. That if the product is 2% less good, they'd still rather the advice. So that's the kind of architect I want you to be. So keep knowing that about data warehousing databases. We're not going to spend a lot of time on data warehousing because that is a career in and of itself, but know that. But the plan is to take the data, to store it, and evaluate it. So let's assume we were using, for this argument's sake, Amazon Redshift. Here's what it's going to look like. Basically, what you're going to be doing is you're going to have some data, and you're going to run some kind of mapping and reduction scripts, which is probably Python Spark and not EMR, but whatever. You're looking for something to do mapping and reduction. So you're going to be pulling stuff out of here. You'll be pulling stuff out of your relational databases with your Python Spark stuff, and those kind of things. So kind of keep that in your mind. You put it into a data warehouse. In this case, we're talking about Redshift because we're talking about AWS, and it's going to be on your certification exam, so you need to know it. If you're looking to real big data architectures and big data warehouses, you're really going to consult to a big data architect. We have one we consult with. His name was Praveen. He's amazing. But that's the point, is you really want to get somebody that's done nothing other than databases for the last 20 years to kind of architect a solution like that. So keep that in the back of your mind. So here's what it looks like. We're going to have scripts that are going to be coming from our NoSQL databases, from our relational databases, from our object storage. We'll write these scripts, populate Redshift, and we'll use a tool like Tabula or Amazon QuickSight. Again, probably not going to use Amazon QuickSight because it's going to work with AWS. We're probably going to use Tabula, which is going to be half the price, and it's going to work on multiple cloud providers. But here's the thing. It's an AWS exam. So we use our buckets. We use the Elastic MapReduce, which we'll talk about in the AWS services section. We stick it in the AWS database, and then we visualize it with AWS tools. So when you're on one of these exams, you know why. So what we're going to do is we're going to spend about 3 more minutes here. I know it's getting heavy. And then we're going to ask questions for 15 or 20 minutes. And then we're going to get into tuning the databases, the fun stuff, the read replicas, the caching, the queuing, the good stuff. We're going to party with that. But let's at least go through this content first. So what is Redshift? It's the Amazon managed data warehouse, and you're using it like any data warehouse to get actionable insights from your data to make better business decisions through business analytics. And Amazon Spectrum, which is their service, again, can provide you real-time insights into your business when combined to other services like S3. Realize Redshift, which is a lot like Postgres, which is what you would probably use for your data warehouse otherwise, which is, again, interoperable and would work anywhere. But there's other options. But it gives you petabyte scale data warehousing, and it's based on Postgres, so you can use SQL queries. But instead of using somebody else's modified Postgres, Use the original Postgres. Use it on Google. Use it on Azure. Use it on AWS. Learn it. Use it on Dell. Use it on Palo Alto, and use it on all the wonderful clouds that are out there. But when we're dealing with Redshift, you still need to know how it works. So when you know how it works, there's the architecture is as follows. You basically have clusters of computing nodes. So that's what Redshift is. You got a leader node and a bunch of follower nodes. They're called compute nodes. The leader and the followers. The leader node gets assistance from the compute node. They support the leader. So the queries are directed to the leader. What's it sound like? In a relational database, you direct the queries to the read replicas. But if you don't have a read replica, you direct them at the leader. Kind of the same thing. So in this case, queries are going to be directed to the leader nodes, and the other devices are going to support it. But it's similar to that. When we're dealing with Redshift, we've got two options. We've got dense compute and dense storage. Dense compute nodes are going to be really powerful, and you're going to use high-speed SSD RAID arrays. And the dense storage one, you're going to use magnetic RAID arrays. Dense compute, high-speed SSD, low latency. Now, dense magnetic storage, guess what? High latency. So it's based upon the application. The last options we're going to talk about is I'll briefly address data lakes. You can go to our page, and let's say on our YouTube channel, we have a discussion with my good friend Praveen. Praveen came to us as a big data architect, wanting to become a cloud architect. A couple months later, he's a working cloud architect, working for a great bank, but he's one of the world's best big data architects I've ever met. And he's really the data lake person. And guess what? We have a multi-hour how to build a data lake, how to architect a big data environment video for you to see on our YouTube channel with no one else but Praveen, who's a magnificent big data architect. So please, Chris, if you can find that, leave a list for people, because I want people to learn from the best. And in this case, when we're talking about databases, Praveen's about the best. So Praveen's with us. He made this beautiful video. It's completely free. Share it with everyone, please. And that's going to be much more information on data lakes. But let's at least describe what is a data lake real quick. A data lake is, realistically speaking, a repository that enables you to store structured data and unstructured data in the same place at any scale. A data lake will hold huge amounts of information, and you don't necessarily have to structure it the way you do in a database. So if you think about this, a database enables you to aggregate all kinds of data in one place. It holds the information. And if we set up our data lakes right, with Python Spark scripts, doing mapping and reduction purposes, we can normalize and harmonize the data and query it. We could even run machine learning on this, and then we can import into visualization tools like Tabula, and we can see so many amazing things. So why collect a data lake? Why build them? Take all this information, mine the information, glean actionable insights from the information, make better business decisions. Better business decisions equal lower costs, increased profitability, less mistakes. So does it make sense now why we're talking about this? That's why we're doing it. That's why organizations are building data lakes. And, this is not necessarily a complete picture, but typically you're going to have something like this. Let's say you had your NoSQL database, your data warehouse, your relational databases. Let's say this data transformation, this mapping and reduction is a Python Spark script. And then what'll typically happen is you might have some object storage. Again, you'll run a Python Spark like that. And then you'll create something called a landing zone, which will turn into a data lake with a catalog. And that's what you're going to write, a big, massive environment that helps organizations make better business decisions. The last thing we do before we take a break, and then after that break, we get into some fun database stuff. I mean, I get a little geeky when we're talking about database stuff because it's cool. I'm a network guy. I'm an infrastructure guy. Been that way my whole life. But we get to talk about stuff that's not my main wheelhouse, and it's cool technology that can help businesses. It's fun, so let's enjoy it. So just remember, where are you going to put your databases? On a virtual machine. What's that virtual machine called? Well, if it's Google, it's Compute Engine. If it's on Azure, it's a virtual machine. If it's on Oracle, it's a virtual machine. And guess what? If it's on AWS, it's a virtual machine called then Elastic Compute Cloud Instance. Just a virtual machine. So what kind of storage do you do in your virtual machines when databases? Well, If it matters, use provision IOPS, guaranteed performance, guaranteed latency. If it's less critical, use general purpose SSD. And if it doesn't matter that much, use magnetic storage. Okay, so now you know. We talked a lot about a lot of database things in a really short period of time. I can take about 15, 20 minutes a question, and then we're going to talk about how do you tune them. We'll get into read replicas. We'll get into all kinds of cool, fun, and exciting stuff, the kind of stuff that we techno geeks really love. So let's have fun. But before we do that, Chris is going to bring in the questions. Please like, comment, and subscribe. If you're not a member, a subscriber, please subscribe and hit the bell. We are going to be coming at you with so many new things. I want you there. If you've just joined us, join on Thursday, tomorrow, our How to Get Your First Cloud Architect Job webinar. You're going to learn so much and it'll be so helpful. And it's completely free, so please sign up. Chris will drive you the link. Next, if you haven't gotten your Certified Solution Architect Associate and Professional books, please get them. The link is in the description below. I think 5,000 people downloaded in the first 3 days. And yesterday, 407 press outlets actually notified the world of this book. They liked it so much. So please go out there and get your free copy and build your cloud architect career. And then, Chris, please feel free to start bringing in questions when you see them.
And some of these questions, of course, may be content that we're coming up to or haven't gotten to yet. So you just you can say that.
I will.
Like the first one I was going to put up was asking about read replicas. So I'm
We're
not going to put
that in 5 minutes.
Yeah. The rest of it, I'm not sure.
Okay. Please explain the elastic networking in a bit of depth. Okay. Do you know what a physical network card is? The Ethernet card in your computer? That thing that you plug your Ethernet cable in? That is a physical network interface. Do you know what an elastic network is? Faith interface? It's a logical version of that. So when you make a virtual machine and you have a fake GPU and you have a fake motherboard, and here you have a fake Ethernet address. It's just a logical one. An elastic network interface is no different than an Ethernet card on your notebook, your server, or anywhere in between. No SQL databases. Does that mean no SQL databases do not follow relational rules? Yes, exactly. They don't have to follow to the same row and column rules. Exactly. You got lots of flexibility on how you lay it out. Manoj, do we need to learn MySQL or other databases being an architect? If you want to be a database architect, absolutely. A big database architect, yes. If you're an architect, what are we? We're people that put the pieces and parts together from the whole solution. So you do need to know databases. You do. You need to know how they work, when to use them, the kind of databases to choose. But I'm going to make this real clear to you, Manoj. When you're designing an architecture for your customer, your goal is to help that customer as much as possible. You will never learn enough in your life about databases as someone that's a big data architect. So if you really want to help your customers, learn the network and the data center stuff. That's the infrastructure, the main things. And then find yourself the database expert. You must know about databases. Like I know about databases, but I am no database expert. I would never, ever design an enterprises-wide databases without getting the consult from multiple database people. Here's the thing. Someone that does nothing other than databases day in and day out for 20 years has 40,000 hours plus of experience of just databases. They will not make the mistakes that our cloud architect will make or an enterprise architect will make. And promise you, if you're a regular cloud architect and you start doing database design, you will be making errors. It'll be like the Linux engineers that are now doing networking, and all of a sudden they're doing networking and the network falls apart because they don't know what they don't know. I read 75,000 pages of networking materials to become a CCIE, Manoj, and you know what? I spent the first 10,000 hours doing nothing other than BGP. I know BGP a lot more than the average Cisco certified internet expert because I've done it my whole life. So I recommend you learning databases and know them well. But also know that you can't know anywhere near what you need to know about databases unless you're a database architect. So when it comes to architecture, remember, architecture is a team sport. How do I design an architecture? I call my best database person. I call my best big data person. I call my best IAM person. I call my best security person. I call my best networking person. I call my best application person. I'm one person. To really design an architecture, I might bring in 50 people to do it. I want to help my customer be maximally successful. No one person can know anything. It could take you 100 years to learn the network, and you still wouldn't know all of it. It could take you 100 years to learn databases, and you still wouldn't know it all. So help your customers bring in the world's best. Doctors that go to school for 8 years, like an internal medicine doctor like me or a nurse practitioner like me, here's what we do. Patient comes in, got high blood pressure. I can write a blood pressure prescription, but guess what? I know how to, but what do? I send that patient to the cardiologist because that's all they do. Now my patient has high blood sugar. I know how to put them on a diet. I know how to prescribe glyburide or something like that for them, but guess what? I'm going to get my endocrinologist consult. Why? Because that's all they do. So when I'm an architect, I care about my customers. I make my customers successful. I make my customers money. I save my customers millions and billions of dollars. How do I do it? I focus on what I'm an expert on. I bring in the world's best experts together. We do it together. Now, when some of these experts call me about networking, I help them. Architecture is a team sport. Build your network. So I recommend you learn a lot about databases, more than we did cover today, because today is the associate level, and I need to have the professional level and then some. But here's the key. Remember, you can't know everything, and if you try to, you will learn effectively nothing about a lot of things, which is the jack of all trades and the master of none. I need you to be solid, coordinate the pieces, bring in the world's best experts, and create the world's best architectures. Networking, Manoj, I recommend a lot deeper knowledge, and here's why. The architecture, the cloud is a virtual network in a data center, so you must know all about that. That's the most critical component. What is the best option to choose to database, which could be vendor agnostic? Well, I would choose MongoDB or Apache Cassandra, but for NoSQL databases. For the data center, or for a relational database, I'd probably use Oracle because all my customers are going to demand that, but I might consider other options from the relational database, like a MariaDB or a Postgres database, for example. But I wouldn't be using any vendor proprietary thing. But I would probably use Oracle because Oracle is going to work on all clouds, and Oracle is an extremely good database. So my customers that reach out to me can afford an Oracle database, and that's what we're going to be using, unless we're going NoSQL. And a lot of my people go NoSQL, either Cassandra or MongoDB. Great question there, Naga. I'm trying to read this, Naga. Naga, if you purchase your own license from Microsoft or Oracle, it doesn't matter where you deploy it in your data center or any one of the cloud providers. You keep AWS and Microsoft out of your Oracle licensing. If you're going to go Apache Cassandra, you deal with them, not AWS or Azure. So you don't have any mediation between AWS by doing it this way, because by doing it, that's how you run into problems. So if you buy your own Microsoft SQL database with your own license, it doesn't matter where you deploy it. So that's the way I would always do it. I recommend getting your stuff directly from the people that manufacture it, because when it comes to support on a database, I want to call Oracle. I want someone from Oracle at the end of the phone. So no, if you ever design an architecture with multiple vendors, which you need to, and something breaks, each vendor is going to blame the other one. So you got to remove them from the equation and make them work together. So if you're using eBGP to connect to 3 cloud providers and you're doing all the routing on your routers, they're not even involved. Get rid of their ability to hold you hostage. Get rid of all of it. Deal directly with your end consumers. You'll get a better product, better price, better negotiation, and better performance, better support, and better capabilities. The same way you would do it for anything else that matters. Chris, do you want to bring on the next one? Raphael, in what scenario would you use a relational database? Well, relational databases are used for processing transactional workloads, like things like people ordered something to know their name and the time. So if I wanted to know the relationships between variables and how modifying one variable affected another variable to make a better business decision, I would use a relational database. If I had unlimited scalability needs or needed flexibility in my schema, for example, or needed things like that, I would use a NoSQL database such as Apache Cassandra or MongoDB. I'd never use anything like a DynamoDB or an Amazon Aurora because they're vendor proprietary, lock you into the system, and don't work across multiple clouds. So NoSQL databases for unlimited scalability, flexibility, and schema. Relational databases to determine the relationships between variables process transactions like somebody purchased something off of a website as a rule. Good question. Chris, what's the next one? What is the ACID model that's used by SQL databases about? Well, let me go over that again. What they're really talking about is what they're really talking about is that they're atomic. And by being atomic, what are we really talking about? Once you make a transaction, it's there. C, consistent. It means that the second you write to the database, it's immediately consistent. Durable, for the D, it means it's available. So basically, when you're dealing with ACID databases, it just means that the second you have the information, it's there. It's all or nothing. It's on there. It doesn't change. That's what we're talking about when we're talking about ACID models. And the second you write, it's immediately consistent for everybody else. And then once it's there, it's not lost. That's regarding the durability. That's what we're talking about with SQL databases. When should you use Elasticache over DynamoDB? They're totally separate things, Joseph. Elasticache is a cache that you would use to accelerate or reduce the load on your database or your web server. So I probably wouldn't use Elasticache either. I would probably set up my own virtual machine with Redis, and that way I could use the same Redis cache that's set up dynamically and identically on all my cloud providers, because Redis is much more of a standard. So again, the Elasticache, which you have the choice to use Redis or Memcached, is an AWS proprietary version of it. So I would use Elasticache, and I'll show you how and when we use caching. And we'll be using that in a minute when we talk about database scalability. You use a NoSQL database when you need flexibility in schema and unlimited scalability. You use a cache to reduce the load, the read load on your systems. We'll talk about much more about caching in the database scaling section, because that is a very important topic. Dragonfly. Can I talk about Snowflake? Snowflake is way outside of this topic, so let's leave that outside of this. And it's not. How do you scale non-relational databases? You partition them. By partitioning a non-relational database, it creates second ones. But we also can use queuing, and we can use caching, which we'll talk about when we get to the database scaling section, which we're going to get to in a few minutes. Great question, though. Amazon Redshift, again, will lock you in. So again, Matt Evercloud, we talked about Redshift. Why did we talk about Redshift? Because we're dealing with an AWS certification, so we have to talk about all those AWS services, even if we probably wouldn't use them. I'd probably use a Postgres, which is what that's made off of. And because I can use Postgres on Oracle, Azure, Google, AWS, and I'm not vendor locked in. So pretty much all those proprietary services, I don't have any use for them. I use vendor interoperable standards everywhere. Now, that doesn't mean that I won't take advantage of some of the transformational benefits of the cloud. There are times where some of these serverless things are so amazing they're worth using, but use them in a manner for which it doesn't hurt you and it's good for your customers. Use that auto scaling in the cloud. It's the greatest thing ever. Use the agility of the cloud. That is the greatest thing. The point is, none of this is all or nothing. Some things are going to perform better in the data center. Keep them there. Some things perform better in the cloud. Some things are better in multiple clouds. Some things are better than a single cloud. What is your job in the architect? To solve your customers' problems. The technology. Whatever technology it is. Not AWS technology, not Azure technology. Technology. That's the key to remember. It's never about AWS. It's never about Azure. It's never about Google. It's about solving your customers' problems and making their businesses better. That's what we do as architects, and that's why we do it as architects, and that's why customers come to us as architects. And that's why they're willing to pay us so much more than engineers, because we're solving business problems. Keep that in the back of your mind. You should be good to go. What are the best uses for NoSQL and SQL? We use NoSQL databases anytime we need flexibility in schema and extreme scalability. We use relational databases when we want to find the relationship between variables, track transactions, etc. Good question. Chris, we can probably do one or two more. What is the difference between a data lake and a data warehouse? Rashi Kumar, there's a 2-hour video that I'd like everybody to see that was made by Praveen. Chris can provide the link. A data lake takes data out of your data warehouses, out of your streaming data, out of your object storage, out of your relational databases, out of your NoSQL databases. You run some Python scripts to do some mapping and reduction. You put it in object storage, which is queryable. And now you can create a big giant environment. That's pretty much your data lake. What is your data warehouse? One big giant database that's got stuff in it. So that's the difference between a data lake and a data warehouse. Mike, why would you see the need for re-architecting Oracle DB to RDS? I think I explained it. Let me do this. If I use the AWS only thing, what happens when I'm in Azure? What happens when I'm in Google? What happens in my Nutanix cloud, my OpenStack cloud? By just going directly to Oracle and getting a license from Oracle, I can deploy that on 3 clouds at the same time. So when AWS has an outage, I don't care. Google is up and Azure's up. When Azure has an outage, Azure had a massive outage this year. It doesn't matter. AWS is up. When Google had their massive outage about a couple weeks ago, it didn't matter because AWS and Azure were up. See, these cloud providers are great. They're the best operators in the world, but everybody has outages. Everybody. That's why nobody would be stupid enough to use one service provider for their WAN. 30, 40 years ago, they were teaching you never put all your eggs in one basket. You can't use more than one link on AT&T. What if it goes down? So when we're dealing with the cloud, we can't be using 4 or 5 the same software. It's like trying to put all your network on just Verizon. Verizon's incredible. It's one of the best ever. But Verizon's going to have outages. I can't put on my network in AT&T. Why? AT&T is one of the best networks in the world. Guess what? They will have an outage. And if I use only AT&T multiple links, I'm going to be down because I have an outage because stuff goes down. So don't lock your customers in. Second you go vendor proprietary, you've lost your redundancy. You've lost your availability. You've lost your ability to leave. So that's why I re-architect. And that's why I don't use the standard cloud services, because they lock you in. They put your customers in a bad position. They can't change anything when they need. So I wouldn't be re-architecting anything. I don't need to. When most people go to the cloud, if they want to go and take it from, like, say, their run database to go run on Aurora, they have to redesign everything to stick it in Aurora. But if they're using Oracle in the data center and they go Oracle to the cloud, there's no shifts, there's no changes. And we're trying to make it as easy in, on, and off the cloud. We're trying to make it that if one cloud fails, you're still good. So if you're using normal services, you're not going to have these kind of problems. And that's why we recommend these things.
All right, Mike. So we've got one more that we can do before we get back to the content.
Sure. Scuba Racer. Other than technical knowledge, a critical knowledge for AWS architects is to be able to articulate and communicate well in English if you're trying to get a job in the US. Let's be fair. Communication skills are the most critical skill for any architect anywhere. Anywhere. Why is communication skills the most critical thing? If you can't ask the customer what they want, you're not going to know what to design them for them. So it's not for AWS architects, it's for all architects. There's no other way to do the job unless you can communicate it in the language that you're going to be working in. So if you're in France, you're going to be speaking French. If you're in Germany, you're going to be speaking German. If you're in Greece, well, you'll probably be speaking English because it's a small country, but you know what? I'll be speaking Greece because I speak fluent Greek. So it's about speaking in the language. You must be an excellent communicator. But what you have to say needs to be right. You need to be able to articulate things. So if I'm the executive and you're telling me about my database, that's not the right message. If I'm the executive and you're telling me about a database, I'm going to escort you out of the office. I don't care about the database. So, that matters. But let's be real. English does not have to be your primary language. It doesn't need to be. And if you've got an accent from coming from somewhere else, it's okay. When I leave a room, I say, close the lights. Or when I walk in the room, I say, open the lights. In America, people look at me like, huh, what? But half of the world knows it because English is not what I speak at home. I speak Greek at home. So if you come from somewhere else, great. English is not the business language of the world. If you go to Spain, nobody speaks English. If you go to Miami and conduct business, it's in Spanish. When I worked in South America, all business was conducted in Spanish. Certain English is a national business language, but not everywhere. They don't speak English as the primary language in Germany. It's German. And in France, it's French. Yes, French people know how to speak English, but all business is conducted in French. So, keep that in mind, that it's really not about that. You have to be able to communicate well, but there's a difference between being a native English speaker and not. And it's okay to have an accent. It doesn't matter. It's okay to use any language that's there. Every language uses different things. You're going to use a different language and even a different English in England than you do in the US. I use different spell checks. Most of my work is outside the US, so I use a UK spell check. But here's the key. English is not the only language. There's lots of languages. I get asked to do consulting in Arabic all the time, and I don't speak Arabic. I wish I did. There's over 1 billion Muslim people in the world, and they speak Arabic there. And yes, there are some people that speak English, but there are a lot of people that speak Arabic. Now, in India, it was a British colony, so most people speak English, but not everyone. And guess what? They don't need to, because there's lots of work that can be done there. So expert communication skills are necessary, but I'm not going to tell everybody they need to speak English. They need to be an expert in their language, in the language of their customers, and the language of their business's customers. And that's going to be different. French is all over the world. Spanish is all over the world too. African countries, there are countries like Cameroon that are French, or Ghana that's French. I have Cameroonian students, they're working as cloud architects everywhere, and they learned English when they got to America a year ago. And French is still their primary language. I've got students from South Africa that speak English, but Dutch is a language they speak. Well, it's not actually Dutch, it's Afrikaans, but whatever the case is, it's there. And I've got people from Spain and South America that are going to speak exclusively in Spanish. Again, huge populations. So let's go out there. Let's maximize our communication skills, written communication skills, oral communication skills, presentation skills, and let's serve the customer in the language of their choice. That's how you build relationships. So it's not just English. And that would discourage anybody, and it would be wrong, and it would be inappropriate. We must communicate well in the language that our customers are at. That's the key differentiator. English is a lot, but not everywhere. Chris, you want to bring in the next one?
The rest are not about the content.
Okay, well, let's get back to the content then. If you're having a good time, please subscribe, hit the like button, and don't forget to join our How to Get Your First Cloud Architect Job webinar. Please subscribe for that. I want you all to be great, but don't worry about the small things. Know how to solve your customer's problem, develop the business acumen, the leadership skills, the emotional intelligence, communication skills, and most importantly, be you. Let the world see you. Let the world see the greatness in you. Let your light shine through. Let them see your own unique individuality and leverage all of that to help your customers solve business problems. And don't worry about the rest of the nonsense. Focus on the big picture stuff. Okay, so let's get back into talking about, databases and scaling them up. Let me see where I actually put my slides here so I can remember. I've got like 4,000 windows open on a whole bunch of monitors.
Mike,
yeah.
Sorry, I did just see a comment. It says, what is RDB?
RDB?
Is that going to be a relational database? Just to clarify.
They're typically called RDB or RDS, so relational database. A relational database is something that shows the relationships between rows and variables.
I think it might have just been an abbreviation that was used previously and somebody was asking for.
Yes. Okay, one piece of advice that I'll give you all. If you want to be an architect, don't ever use acronyms or abbreviations. Your customers have no idea what they mean. None whatsoever. And guess what? And Kevin, Akeflu, seriously, it doesn't matter where you're from. I have students in Cameroon getting hired every day, Nigeria hired every day. I have Pakistani people getting hired every day that speak Urdu, which is just like Hindi. Be you. Be in the language of your choice and go out there and help people. We're all from different worlds. There's 7 billion people in the world, or less than that. How many of them are Americans? 330 million? How many are Canadians? How many are in UK and Australia? 1/7 of the world or less. So let's be ourselves. Let's go out there and let's help each other live better lives. That's what I care about. I don't care about English. I care about the world. I want us all to be better. And I want you all to be great architects so you can make the world a better place in any language or country of your choice. So let's get back to this database content. But thank you so much for that, Chris. So let's talk about how do we optimize the performance in our databases. So databases are not like other devices. If we have 3 web servers and we want to load share, what do we use? We use a load balancer, and it's great. Load balancer does this, but we don't do this on databases. We can't load share across 10 databases by using a load balancer. So kind of keep that in mind. So when we come about database optimizations, we're going to talk about a few things. We're going to be talking about backing systems up. We're going to be talking about encryption. We'll talk about creation of scalability through read replicas, caching, and queuing. We'll talk about high availability on a single cloud. We'll talk about high availability across clouds. So keep that in your mind. So the first thing that we're going to talk about is backing up the database. So if the database is an extremely important part of your system, and it's got all your critical business data, and the database were to fail, and we lost our data, guess what we have? Nothing. We're done. We're lost. Does that sound like a good scalable way to have all of our stuff in a single environment, and then if we lose it, it goes away? So what do? We create backups. Now, the good news with AWS, if you're using any of their databases, off the rack, they're automatically backed up, which is pretty nice. Now, when it backs it up, it doesn't just back up your data. It backs up the whole drive. So you back it up, it becomes an image of your machine, which means if your database ever gets lost, all you have to do, launch that new image. That new image is going to come up with a new IP address and a new DNS name, which you're going to have to address. But it's going to be exactly the same server, bit by bit copy of everything on that drive. So by doing this, you are getting the best backup. I will tell you that the AWS and the cloud type backups that make an image of your system are the world's best backups. They are the best, fastest things. We could do it in the VMware environment by creating backups of our virtual machines and storing in our storage area networks, but this is awesome. Their AWS backups are among the best I've ever seen in 20 plus years of architecture. They're amazing. And basically the backup happens. Now the backup, you can retain it from 1 day to 35 days. And if you chose to move this back up to your object storage, you can keep it for much longer. Note when you're backing up the databases, except for DynamoDB, when you back them up, your performance of the database is going to be very degraded for a second or two, maybe even unavailable, but then it'll come back. So decouple your application architectures, add some queuing, you're going to have lots more, and we'll talk so much more about that. So keep that in the back of your mind. Now, when you're backing up a database, it's in the form of a snapshot. So you take your data and you create an image of it. And basically, it is a complete and total bit-by-bit plain and cut background. So if any of you guys ever used Semantic Ghost many years ago to image a Windows system, or you used like any of the imaging things, that's what this is. It's just an image. Now let's talk about how would you restore from that image. You take the image, you launch, but it's identical bit by bit. But remember, it's going to have a new IP address, which means a new DNS name. So if your application servers are pointing to an IP address or a DNS name, you're going to have to change that because it's going to come up with a new IP address. Otherwise, it's identical. So kind of keep that in the back of your mind. Now, if you're going to store your information on a database, and it's going to have vendor proprietary stuff. So I'm looking at the group right here. I see some of my amazing students plus other people. If I have John Clark's, Eva Doikia's, Chow, Cafe Memories, and I don't want to mess the name, and Anil's information all in this database, their proprietary information, their personal information, and I get hacked, a lot of people are going to be upset with me. So I can't do that. So I need to make sure that my systems are secure. So how do I secure the data in my database? I encrypt it. How do I encrypt it? What kind of storage are we going to be using in AWS? We're going to be using EBS volume, block storage. No, we'd be using the same equivalent storage on Google and Azure and Oracle. We're going to be using block storage. Same for OpenStack Ansible, same for Nutanix. But that's the key. It doesn't really matter. We're going to store it, and we're going to store it and encrypt it. Now, when you're dealing with AWS, how do you encrypt your storage? You pretty much just enable the key management system and poof, you now have encrypted storage. So when you're using the key management system, remember that it's a managed key service, which makes it easy to control your keys, but you're not in full control of the keys. Kind of keep that in the back of your mind. We talked about yesterday under object storage, and if you want to go back to yesterday's, if you're not 100% sure with regards to some of the things that are there, go back and go back to the encryption options. We talked about customer managed keys, AWS managed keys, the key management system. So go back and get that because it's pretty important. Now, when we're dealing with databases, they also support transparent data encryption. So if you were going to be using an Oracle database or a Microsoft SQL database, which chances are customers are going to be using an Oracle database, especially if they're an enterprise, remember, they naturally use transparent data encryption, which is really cool. Transparent data encryption is encryption and decryption on the fly. So when our data is written to storage, it's encrypted, and it's decrypted when it's removed. So you're secure, you're there, and it's really, really great. So kind of keep that in the back of your mind. You can also use this Cloud HSM, which is a hardware device for storage and management of your encryption keys. It's a great environment and a great setup. So let's talk about encryption in transit. You can encrypt your data on the way to the database and the way back. And, kind of keep that in mind. So realistically speaking, kind of keep that in mind. So how does this, encryption in transit work? You create an SSL certificate, for example, and with that SSL certificate, it's used to verify the endpoints and encrypt and decrypt your data, just like any other website thing. So kind of keep that in the back of your mind. Now let's talk about scaling these databases. Since the database is so critical and so important for business function, we have the opportunity to scale it. Now there's two ways you can scale it. Now we can't use load balancers like we can with other servers for databases. So the simplest thing to do would be to use a bigger server. So let's say I've got my database on a 32-core server with, a terabyte of RAM. I could move to a 128-core server with 4 terabytes of RAM. That's scaling up. Go from mini server to a big server. Now, do you think that's going to work? Do we think a 128-core server with 4 terabytes of RAM is going to serve the whole database needs of a huge client enterprise? No, not at all. We might need 30 of them. I'm exaggerating, but if we didn't do any caching or killing, we might need 30 of those big monster servers. So what that's called scaling out or adding additional servers, because you can only scale up so much. Once you get to that server with 256 cores and maybe 8 terabytes of RAM at max, you've got no headroom. There's no more. So what we do is we scale out. And because we can't add 10 more servers and load balance them with the load balancer, we have to use a different type of scaling with databases. So that's why database scaling is tricky. That's why people get it confused. You will see probably 20 questions in your exam on databases. And this stuff, the scaling is really, really critical because this stuff you need to know. When people ask, I'm a cloud architect, do I need to know this? You need to know this. There's no way around it. Now, choosing whether you use MongoDB versus Apache Cassandra based upon read-write load, go ask your favorite cloud big data architect for that. But this stuff you need to know, fundamental concepts. So we're going to talk about scaling. First, we'll talk about dealing with NoSQL databases like DynamoDB or Cassandra. All we need to do here is very simple, is this. We partition the database. It chops it into shards, which is partitions, and it breaks the database into multiple pieces. And the application will route the data to the right shard. Beautiful, beautiful system. And of course, we can use caching, and we'll talk about caching later when we get to it. But with relational databases, we don't do that. We don't partition it. What we do with relational databases is we add something called a read replica. So what is a read replica? So let's say I'm here. I'm sitting in my chair. I am the master database. Right now, I'm talking to you, and I'm seeing questions coming in. I'm talking to you, and I'm seeing questions coming into you. Now, think about that. If I'm truly talking to you all day long, my brain's busy. So what happens is if I'm talking and answering questions and talking and answering questions, and 1,000 queries come in or questions come in at the same time, I can't address them. So they're dropped. So what happens is a read replica is this. Right now, you can see a few of my amazing people on the call. I see an Eva Doike who's got a blue wrench by her name. She's one of my special disciplines, and she's moderating some comments. You see Chris Johnson with a blue thing on his name. So when the questions are coming in, they're being directed to the Eva Doikes of the world, to the Chris's of the world, the people that blue wrench. They're responding to those questions while I'm talking, which enables me to focus on talking. The same thing, I can focus on talking while my team is focusing on some amazing things. So kind of keep that in mind. So what is a read replica? Primary database, you put a couple of readers. Here's what happens. The primary database is talking and responding to messages, writing messages and receiving messages, two ways. What we do is we add these read replicas, and then we point all the questions or all the queries to these read replicas. And by doing that, Brandon's another read replica that's out there. For example, he's got that blue wrench. Brandon's answering somebody's question right now. I didn't even see the question, so I can keep doing my thing. So read replicas do this. They're copies of the database that are read-only copies. And we point all our questions to the read replicas, which lets the master database not answer any responses. So the master database can be focusing. So when you see Brandon over there, Eva Doike over there, maybe Jawad's got a thing next to his name, I'm not sure. Chris has got a thing. They're answering your questions where I'm talking. They're feeding me the questions. So that's what the read replica does. They enable me to focus on just writes. So kind of keep that in your mind. So the read replica enables you to send all the read traffic to the read replicas. And because all the read traffic isn't being sent to the read replicas, it's sent to the read replicas and not me, I'm free. I have more resources to deal with more writes. That's what read replicas are. That's how they help. They offload the main server with read requests. So a read replica is effectively an identical copy of the database, read only, except for MariaDB. And it's synchronized in like near real time. So it provides these extra servers. Like my amazing people, Abigail Marks is there, right there with a thing. She's helping right now. Brandon Bowman's there helping right now. Eva Doike is there helping right now. They're my read replicas. They're also some of the world's greatest cloud architects. Brandon's cloud security architects. Brandon Bowman is one of the world's best cloud security architects. Jazz, an exceptional cloud architect, and he's there too. So they're functioning as my read replicas, helping me deliver better service to you. So that's what we're talking about. That's what a read replica is. Eva Doike is out there. She amazes me every day. Felix, thank you so much. Felix is a lawyer who's also a cloud architect. We have some amazing people. And Eva Doike, we love you, all of you. And I'm so grateful for your comments. I'm so grateful for your thank you. Chris and all you guys, Jawad that's out there, Brandon out there. Thank you so much. I love you for doing this for the community. You are helping people all over the world right now. So thank you for helping us help others. Now you know what a read replica is. My students and my disciplines are not exactly read replicas. They're important, critical people. They're some of the world's greatest architects. But, I wanted to use that to make sure people understood why. So keep that in your mind. So what's it going to look like architecturally speaking? It's going to look like this. Typical three-tier web app. You typically have multiple web servers front-ended by a load balancer, multiple app servers front-ended by a load balancer. And here you've got your database and a couple of read replicas. And they're taking over all the reading, all of that stuff. So they're sending it right then and there. Keep that in mind. Send your queries to these guys or girls, whatever you want to call them. And this person in the center is just calm and happy and relaxed. Kind of the way I'm able to worry about talking and answering questions as opposed to seeing all those beautiful messages that are coming in, and they're great. That's the concept of a read replica. So when do you use them? When there's a lot of read activity. If all your activity was write activity and you added read replicas, it's not going to help. So when do you add them? When queries to your database are slowing it down, add a read replica. Read replicas, remember, are from performance. Read replicas boost performance. They do not provide for disaster recovery. So keep that in your mind. Read replicas provide performance, not disaster recovery. So what is caching? That's the next thing we can do for relational databases and NoSQL databases. So let's say this. Let's say Eva Doike, Abigail, Brandon, Jazz, and Chris, all those people with the wrenches, they're let's say they're answering your questions constantly. They're answering your questions. You're querying them. They're giving you the world's greatest answers. Now, let's say 40 people ask, what is a relational database? Do I really need to have all 40 of them keep answering, all 4 of them answer that question 40 times? Or can I take that database and then can I create an in-memory environment of the frequently asked questions, and then they can answer it once, and then all the other people that ask that same question get sent to DRAM somewhere, so they don't even hit the database. That's called caching. So the way you might use a cache to offload a web server, and we'll talk about that a lot when we're talking about CloudFront and content delivery networks. And the AWS content delivery network CloudFront is awesome. And we'll talk a lot more about that. But caching. So if 40 people ask, when do we use a read replica next? And Brandon Bowman answers it the first, and we have a cache, all 39 extra people that ask that same question are going to get answered by the cache. And now Brandon's, chilled out. He's in his house. He's designing his next cloud architecture. He's designing his next security thing, and he's there chilling out. And now somebody asks the same question. It gets re-answered, gets re-answered, gets re-answered. Somebody asks a new question. Now the question comes in. Does it go to Abigail? Does it go to Eva Doike? Does it go to Brandon or Jazz or Chris? But that's the key. So we're using caching to offload our read replicas. And we're using our read replicas to offload. And I'm going to architect this. We will map that, make sure you understand it visually. But that's what we're doing. We're using caching to reduce the load on the read replicas. And we're using queuing. Well, we'll talk about it, but we're using caching to reduce the load on read replicas. So here's the way it works. Somebody asked the question right now, what is AWS? It's never been answered before. One of the 4 read replicas will answer it. Then it'll be stored in a cache. The next time somebody asks that question, it goes to the cache to get an immediate answer until the cache time's out. So kind of keep that. That's what we're doing caching. That's what we're doing that's what we're doing caching. Now caching is going to help with read reduction. So when you're working with AWS, they've given you 2 pre-made versions of the cache. You can use Elasticache. What is Elasticache? It's a cache that has to have the word elastic. Why does it have the word elastic? Because AWS strips the word elastic in front of everything. So when you strip off all that elastic nonsense to really figure out what you're getting, you've got 2 cache options, which are Memcached and Redis. Redis is one of the world's best caches for databases. So, extremely rich feature set, very good performance. And guess what? If you're using a Redis cache in your data center, you can take that same Redis cache on that same virtual machine, copy it to the cloud, copy it to all 3 clouds, and poof, you're up and running. Or if you chose to go to the AWS proprietary version, you could use Elasticache. Whatever the case is, it's just a Redis cache. Strip off the naming, get rid of all this elastic, take the words elastic off of everything, and you're going to know what you're doing. So drug companies pay people millions of dollars a year to name things. Cloud providers pay people millions and millions and millions of dollars a year to obfuscate things. And here's the thing. If they really called east-west routing, which they just released as a brand new feature, which is called routing between subnets, which Cisco did in 1980, you couldn't issue a press release in 2021 and say, guess what? We now support east-west routing. How would you support a press release to something that's 40 years old? You couldn't. But if you call it something different and you make it sound exciting, it's interesting. Elastic Compute Cloud. It's a virtual machine. VMware had it 20 years ago, but it doesn't sound cool. So Elasticache, you've got 2 options. They're the same 2 caches you've always chosen from. Memcached, which is simple, elegant, and not super function rich. And Redis, which is this beautiful Israeli cache with lots of features and functionality. It's amazing. So those are your 2 options. I think they're Israeli. Actually, one of the architects that I trained who worked for Red Hat as a Linux architect that I know, one of the best people that's developing our Linux architect program, our Linux program, he actually works for Redis now. He was one of the people that I trained, but he worked for Red Hat first. So pretty familiar with Red Hat for those reasons. So let's talk a little bit more about the caching. The caching reduces the load on the read replicas. So when do you use cache? Again, when you've got a lot of read traffic. How do we improve scalability? Caching to reduce the load on the read replicas. Now, here's what this is going to look like architecturally. Here we go. We've got our web servers, our app servers, and our cache on the way to our database. Now, the last thing I'm going to talk about right here, and then I'm going to architect it out with you, is the following. Queuing. What is queuing? So for the Americans that are out there, queuing means form a line. For the people in England, Canada, and Australia, when you go to an airport, they say form a queue. And everybody knows that a queue is a line to be scheduled. But for the Americans, when I learned about queuing 30 years ago, what the heck is a queue? And then I went to England and it was clear to me, but that's neither here nor there. But queuing is basically a means to schedule the delivery of your messages. So, database server here. If I have 1 million messages coming into the database server right now, and the database server can only deal with 500,000, I'm going to lose 500,000 requests. But if I have 500,000 requests coming in from application servers, and I can stop and hold them in a line, and then let them feed out of the line into the database on a one-by-one basis, now I can reduce my write load by smoothing it out. So now I can offload my reads with the read replicas. I can protect my read replicas with caching, and I can reduce the write throughput with queuing. So here's what it's going to look like. And at this point, what we'll do is we'll have a nice architecture lesson. It feels like after this, we should whiteboard it out and build some pretty databases. Here's the concept of the queuing. Sender sends a message. It gets deposited in this holding pattern. The message gets, when the time the receiver has capacity to take it, they pull the message out, it gets removed from the queue, and then the next message goes through. So it's a scheduled way to do it. Now, when you're dealing with queuing, of course, you got two options. You can build your own message queue. Or in this particular case, the AWS Simple Queue service is truly great. It's a pre-built queue. It's an excellent service. You've got two options. The first one is a standard queue. Messages get drained from that queue as fast as they can. Highly, highly efficient. Now, if you've got a message that's 1,500 bytes versus a message that's 64 bytes or 80 bytes, you know what? The 80-byte message, even if it's sent second, might get there faster than the 1,500-byte message. So the standard queue just gets rid of, takes the messages and gets them out as fast as they come in. But some applications require ordering. So that's the case. You can do what's called the FIFO queue. For any of you that are used to accounting, we talk about first in and first out. It's the same concept here. So keep that in your mind. So let's really show you how queuing does its thing. So I want you to really look at this environment. Let's assume you've got a database, and let's pretend this is the capacity, whether it be disk or CPU or memory. What you're going to have is you're going to have times where it's really relaxed, and then you're going to have times where it's going to go high utilization and then nothing, and it'll go up to 100% and it'll lose messages. And then some of the time it's going to be resting here. But if in between your web server and your app server and your database server, you have this queue, instead of having all these peaks and valleys, the server is going to be, somewhat busy all the time, but it's not going to be really crushed. So that's what we're talking about. That's what we're trying to do. We're trying to deal with this concept of crushing, or not crushing the server, smoothing it. Because you know what? I might be able to run it. Well, I can't run after my foot injury, but I used to be able to run about 6 kilometers in about 30 minutes. So, that was me. Now, I might be able to run at 24 miles an hour for a short period of time, but not long. So if I was running a race, instead of being up, slow, start, slow, fast, maybe I would run that race at my lactate threshold, that point where I'm running as fast as I can without building up too much lactic acid. And then when I get to the end, cross that lactate threshold. But that's how I program it for a fitness person, for example. Same thing here. I don't want my server to be at 100% and then 0%. I want it happy and smiling the whole time. So that's what we're talking about by queuing, and that's what it's doing. It's smoothing out the rough patches. So what does this look like? We're using the queue to reduce write load. Read load gets reduced from read replicas. Read load gets reduced by reducing the caching on the read replicas, so even less has to hit the read replicas. So before we talk about any type of ETL tools and things like that, I want to architect this with you so you guys get the real good feel for it. And actually, that's not where I want to put this. Let me copy the slide, paste it into this presentation. So let's go right here. So let me do this. Let me create a virtual whiteboard, or I'll do the best I can to create a virtual whiteboard. Okay, can everybody see my slides and my desk right now? Okay, so what we're going to do here is as follows. Let's say we have a database. We're going to do a relational database first. We're going to call this relational database. Now we're here. So this is our primary database. This is the master. This is the database that's in charge. We're in charge here. That's our relational database master. Now, if we direct all our users and we send every request we have here, write requests, facing the database, and then read requests, which are basically going to be these going out. At some point, this database is busy. This stuff's trying to get into the database. These are people asking for information in the database. This is ugly. So let's fix it. Now let's take this database and let's give it some help. Let's give it 4 read replicas. So by making it a read replica, we're going to offload. So we'll have this nice little happy copy. We'll call it a read replica. So here we've got our database over here, and we've got some read replicas. We'll have one over here, a replica. Let's copy this whole thing, make another one. Let's add one more read replica. Good. I'll make this a little smaller so we can fit it all. So we're going to have our relational database, and then we're going to have our read replicas. We're going to have as many as we can shove on this thing because we want it to scale. Okay, so we have 3 read replicas. Now, what's going to happen? We're going to point the write traffic directly here. Write traffic is going here. Write traffic is all going to the database. Now, what we're also going to do is we're going to point read traffic to the read replicas. All this stuff is being directed here. Okay, so now what we can see here, we're writing to the database, all our read traffic's going into the read replicas. We're here, our CPU is smooth, the master database is functioning, the CPU is 30%, our read replicas are functioning around 30%, our disk is smooth, life's good, we're all happy. We're having a database party, we're a happy database. Now, we just get a news report that says we've now offered the world's best solution to something. And it's in Newsweek, it's in Business Week, it's in Time Magazine, it's in the Wall Street Journal, it's in The Economist, it's in the New York Times, it's in Investors Business Daily. Now, we get 1 million requests. And guess what? Our read replicas are tired. I can't do it, Mike. I can't do it, Mike. I'm tired. I need help. Give me more soldiers. I need work. So they can't handle it. And what else happens? We start sending the right traffic because everybody wants to order because they found out about us in Investors Business Daily and Newsweek. We were in Investors Business Daily 2 weeks ago. Kind of like that, but that's neither here nor there. So we're writing to these databases, but now we have extreme capacity. Now we're stuck. So how do I make these read replicas happy? What if I stick a cache in front of them? And now the cache is going to answer the frequently asked questions because it's going to store them all in the cache. So now when people go send a request to read something, hey, I'm interested in learning this, the cache is going to answer if anybody's previously answered it. So by doing this, what have we done? We've offloaded our read replicas. So now our read replicas are happy in the party. They're here, they're in there, they're dancing around, they're having fun, they're all happy. Everything's smooth. They're not working so hard. They're happy. They have time for the cocktail hour. Our read replicas are going to a party. They're getting together for dinner and movies, and they're having a party. So the read replicas are all happy because now they're not working so hard. Now, what else? At some point, because we were in all these magazines, we can no longer handle all the traffic coming in. So if it tries to come in at this speed, these 3 messages try to get there, but it can only handle 1, and this one's lost. Now that's not good. 1 of the 3 is lost. Here, this one. I don't want that. So what can I do? Let's take our web servers. Oops, now we're going to have more than one web server, so that probably means we need a load balancer. So let's say we've got a load balancer. Now let's say we've got some web servers. Where are our web servers going to be? On a virtual machine, no less. On any cloud, they're always going to be in a virtual machine, unless you have a dedicated server. So we've got a load balancer, and we've got some web servers. Let's stick in another load balancer for our app servers. Load balancer, let's have some more virtual machines for our app servers. Now remember, our website's so busy that we can't handle all the traffic through these things coming in here because our web server is auto-scaled. Our application server is auto-scaled, but our database can't auto-scale. So what do? We stick this big giant box there, this big giant box, and this box holds our messages. This box is called a queue. But if we're using AWS, we can use their pre-made SQS queue. It's a beautiful queue. So now all these messages come in, these things auto-scale, now they're stuck in here. Now when the database is ready, I got you. Now the next the message is ready, I got you. Next message is ready, I got you. So let's think about this. Now I'm happy because I've got a bouncer out the door of my club, my party. The bouncer's saying, you can come in now, somebody left. You can come in now, somebody left. You can come in now, somebody left. When 100 people try and enter the door at the same time, the bouncer says, no, thank you. You can wait until your time. And that way we don't lose anybody. We don't have a fire hazard. Meanwhile, my read replicas are still partying. They're all kinds of happy. They're relaxed. Our main database is happy. They're all having fun because the queues and the cache and the read replicas offloaded it all. So now we're all happy. We're all relaxed. And that's what we're doing. So if it was no SQL database, all we would do is partition the database. We would still use the same caching to reduce the read load, and we'd still use the same queuing to reduce the write load. The only difference is with no SQL databases, you partition the database, and with SQL databases, you add to read replicas. That's it. The same caching and queuing is used. Hope everybody had fun with our database party. I wanted to make sure that we gave you something that I could explain how it works. So there's some, let's talk about one more thing and then we'll open it up for some questions. I'm sure there's questions and I want you all to know them. Oh, I see Pritapal. Pritapal, if you're the Pritapal that I think you are, Pritapal is an extremely good cloud architect. He's working as an enterprise architect now and we're super excited for him. But he might not be the Pritapal I'm thinking of. So let's talk about queuing. We talked about queuing. Let's talk about ETL tools, or extraction, translating, and loading tools. You've got a database, or let's say it's one database, and you want to take your data and put it into another database, you got to get it there. So a lot of these databases are somewhat proprietary, and there's tools that we can use to make this happen. So for example, we can use a tool that's going to take the data out of the Oracle database and put it into Amazon Aurora, should we want to. Not that I would do that, but we could. Or we could use a tool, hopefully, to get some things out of Aurora to make it to a format that we can use to get to multi-clouds, such as an Oracle database or another generic database that we can use everywhere. So kind of keep that in the back of your mind, that we're going to be dealing with a lot of databases. They each have their own strengths and weaknesses, and we may need to use multiple. So one of the things we can do to get data from one database to another is with an ETL tool. So think of it about as an extraction, translation, and loading. Now, you can have your own ETL tool. Lots of organizations do. Commercial ETL tools, or you can use the AWS ETL tool, which is called Glue. I don't care what you use. Personally, I'd probably develop my own ETL tool or buy a commercial ETL tool. Why would I use a commercial ETL tool? Because I want to go from my data center to 3 clouds. So that gets me out of Amazon proprietary stuff. which gets me into, again, the vendor neutral and interoperable. But for your exam, you need to know about AWS Glue, which is the AWS branded extraction, translation, and loading tool. And you can use that on AWS. Or you could use a more commercial product that will work on every cloud, which is what I would do. But you can do it to know that. Glue is a pretty nice tool. It basically discovers your data and catalogs your metadata and makes it searching and queryable. So it's going to look like this. It's going to look like you're going to have your storage, which is going to crawl your stuff, and it's going to pull your stuff from all your places and put it into something for visualization. Okay, so I know that I have spent a fair amount of time talking about databases, and we haven't taken a break for questions in a few minutes. So before we do this, we're going to bring your questions. If you have not subscribed, please subscribe. If you've not hit the like button, please hit the like button, and please hit the bell to make sure you'll be informed of future sessions, because we're going to be doing a lot from free CCNA training to this month, and I'll probably do a live architecture lesson, and I want to do a lot of things to make sure you can have the best cloud architect career, solution architect career, enterprise architect career. So please hit that bell, because we're going to be pushing a tremendous amount of content this month. Our goal is to help the world get cloud hired, build better lives and better futures wherever they may be. So Chris, if you want to bring in some of the questions.
All right, so we're going to go back 30 minutes in time. So some of these questions, again, we may not have gotten to the content, or you may have covered since they would come in. So here we go.
And it looks like some of our read replicas, our incredible team, have probably answered some of these. So let's not dwell on the ones that our team was kind enough to answer. And we're very grateful for Eva Doike doing this, and Chal doing this, and Abigail doing this, and Jazz and Brandon Bowman. Thank you so much for your help. Pawan. So by default, we create a. I'm trying to interpret this. Bear with me a minute. Now, as a rule, nothing is created in multiple availability zones unless you tell it to be. So you're going to have to set it up yourself. Nothing by default is anything, if you're going to use one of the databases that you're going to need to use. So no, it's not going to do this unless you're using things like DynamoDB. So we have an encrypted database. It means it's data inside. Okay, so let me try and translate this to myself first. The hard drive where your data is stored is encrypted. So it's going to be like encrypting any other hard drive. That's how it's going to be. So the whole database is going to be encrypted. And encryption has no ability for anything to read it or not read it as long as you have the decryption key. So it's never going to be a problem. You just, like, the hard drive on your computer is encrypted, but you log in with your username and password, and because of that you have access to it, it's going to be the same thing. Kenny, no, database backup. How do you capture the transaction of a hot database without shutting it down? All you simply do is it's automatic and it's default. You just create an image of your system. But when you do it, like I described, it's going to make your system either extremely degraded or unavailable for a second or two. It's part of the way backups naturally work. How are read replicas different than a secondary database? Read replicas are read-only copies of the database. I don't know what you mean by a secondary database, so I can't answer that second half of the question because it's totally unrelated. Read replicas, I got a database and I've got multiple identical copies of it. So, Pierre, have a master RDMA's clusters starting getting as improvements. Pierre, I'm not completely sure on this. It's a great question to ask. My life is not focused on databases, and I use standard traditional databases. So I'm not really there to give you the best answer on that question. I don't want to comment on things outside of my area of expertise. Jamie Sharon, what happens when there's write load as opposed to read load? Well, by pointing, read load, because generally speaking, if you've got a database, you're not going to write to the database if you're not going to read it. You might, but generally you're not. So you use the queuing to reduce or smooth the written load to the databases, and you either read replicas, etc., and caches to reduce the read load. So most cases, there's going to be a lot of read load, and that's what you're doing. But if not, you're going to have to get away with queuing, and you're going to have to use much and much bigger servers because that's going to be your only option. Roni, what's the use case of memcached? In reality, I've never used it, and I've never seen anybody use it. If you need a cache and you want something real simple and cheap, you're using memcached. The reality of it. If you need anything good with performance and features and functionalities, you're using Redis. So I don't know anybody that would be using a memcached if they'd be using Redis. Reality is so. Most of the things that I work on are people that really need the best performance, and they're going to go Redis and not even going to think about another option. What is the meaning of synchronous versus asynchronous? Synchronous, real time. Synchronous, you heard the clap real time. Now, if I did this clap and 10 seconds later you heard it, that would be asynchronous. Synchronous is real time. Asynchronous means non-real time. Grace, you can bring in the next one. How do you reroute those queries? You point your application dashboards to the queries. You always have to pick a server. You just choose a different IP address. Chris, you can bring in the next one. Pawan, it's pretty clear if you're writing the message to a database. You send a transaction in. It's kind of like talking to you. If I'm speaking, you're listening. That's writing. And when I'm listening to you, and when you're talking, I'm listening. That means I'm going to write it, but you're reading. I'm reading the information from you, and I'm writing it to me. I don't know how you wouldn't know. When you open a door, you know you opened a door. When you close the door, you know you close your door. Message comes in via the mail, it's written. You send an email, it's read. Same kind of thing. So maybe I'm misunderstanding the question, but when you send, it's effectively someone's reading from you. And when you receive, it's right. Chris, if you want to bring in the next question. Great question, Mohammed Idris. Can you use an F5 load balancer here in the cloud? Well, you wouldn't use an F5 load balancer to load balance databases. We don't use load balancers to load balance databases. Now, Mohammed Idris, let's say you're on the cloud and you need a really good load balancer, and you need a load balancer with more features and functions than the proprietary cloud load balancing functions, whether it be an Elastic load balancer or an AWS, an Azure load balancer, a Google Cloud load balancer. What do? You go to that marketplace and you get yourself your F5 virtual load balancers. And what do? You front end them with an AWS network load balancer. And the load balancer provides redundancy against your virtual appliances. So yes, lots of times we use F5 load balancers in the cloud. Same way we use Cisco firewalls, Palo Alto firewalls, Fortinet firewalls. I mean, we're not going to be using WAF, especially in a multi-cloud. So we're going to be using industrial grade firewalls. In order to do that, we're going to have to go to the marketplace. So that's how you use an F5 load balancer in the cloud. And there's lots of good reasons to do so. And I do it all the time. They call it an elastic load balancer sandwich. Here's why. Because normally your F5 load balancers are redundant, but not in the cloud because they're sitting on virtual machines. So we use a load balancer to provide the high availability to our F5 load balancers, which have the real application intelligence and the enterprise grade load balancer functions that we really want to use. So yes, we can do it and do it all the time. Chris, you can bring in the next one. Mervin, how do you keep the data in sync? If the master is updated 10 seconds ago, the read replicas will automatically synchronize and be updated within 10 seconds. Remember, relational databases are atomic, meaning the second they're written, they're consistent everywhere. No SQL databases could take a few seconds to sync up. But remember, they're relational and they get copied very fast. You don't have to worry about that. Ronald, so you basically use a cache as a network load balancer? No, not at all. A network load balancer is a load balancer is a device that provides availability and performance by load sharing. So send message 1 to server 1, message 2 to server 3, message 3 to server 4, message 4 to server 5, message to 6. That's what a load balancer does. A cache basically is you went to a web page And 5 minutes later, you want to go to the same web page, so you don't have to go to the web page. Your computer stored it in this memory. That's a cache. So completely different technology. We'll talk a lot more about load balancers either tomorrow or the next day on our bootcamp. Q regarding SQS. You didn't mention vendor lock-in for the service of the cloud agnostics. Do you condone the use of SQS more than you do with DynamoDB Elastic Cache? So I don't use Elastic Cache because I'm going to use a straight Redis cache. I'm going to use that identical Redis cache from 3 vendors. So I'm not going to use any vendor proprietary anything. Would I be using an AWS SQS queue? Well, if my team already made a pre-made queue and it was pre-coded, yeah, I wouldn't be using an SQS queue. I'd be taking a virtual machine with my own queuing system that was set up by my application developers. But the SQS queue is really good, and it's really functional, and it's really easy to use, and it doesn't really cause that kind of vendor lock-in that we see with some of the serverless things. And for the most part, every cloud provider has a cloud-native version of their SQS queue that, I can consistently see in my environment where I've got my load balancers, my virtual machines, my load balancers, my application servers, and whether I'm running an Oracle database or a Apache Cassandra database or whatever the case is, I'm probably going to use an SQS queue with AWS unless I have one that's pre-made. And the only reason is it's simple. But each cloud provider has their own, and they're basically the same. And it's not like trying to use AWS's WAF and security and then using the Azure firewall solutions where they're all going to be different. And we're not going to have the similar strong security where we want to use the same Cisco firewall everywhere, the same Palo Alto firewall. It's not like that. The SQS queue is something that I would use because it's a pre-made, very simple to queue to use. It's cloud native and relatively easy. So I might get away with it. But if I had a queue that my team already made, I'm going to keep using it. Can I talk about database sharding? Database sharding or partitioning is just partitioning of the database in order to give it more partitions. Chris, we can probably do about 1 or 2 more. What's the difference between strongly consistent and eventual consistency? That's a great question. Strongly consistent. I write. A millisecond later, you read it, it's there. Eventually consistent. I make a database write. 2 seconds later, it's there. Instead of instantly. That's the only difference. Why would you front end a load balancer? Good question. Let me show you that, and then we'll go back to this. This is heavy-duty architecture. So I'm always happy to take a break and do architecture because this is really important. Okay, so I want you to think about this. In your normal data center, you got your load balancers. You got your nice F5 load balancer, and you got another nice F5 load balancer.
Hey, Mike, do you mean to be sharing your screen?
Yes, I do. Thank you. So in this environment, we've got 2 load balancers. We've got an F5 load balancer. Now, these are high availability devices. We might point our, and everything's going to work. They're load balancing between our redundant servers, and everything's good. But why can we do this? This F5 device that we're sticking in the data center is a high availability device. So it's going to synchronize and do stuff with the data centers. Now, this is the data center. Now we're on the cloud. Now, this F5 device is a virtual machine. And this F5 device is a virtual machine. What happens if a virtual machine crashes? Is it high availability? No. Now, your F5 load balancers are high availability, but your virtual machines are not. So your virtual machine crashes, you lose a load balancer. And nobody's going to know that this virtual machine crashed. So what's going to happen is we're going to have half of the traffic coming into here and half of the traffic coming into this load balancer. And now this load balancer goes away, but half of the traffic is going into this load balancer. And guess what? We black holed half of it. By comparison, if we can stick a network load balancer over here, and a lot of times in the data center, you're still going to use network load balancers for this reason. If we can stick a network load balancer here, the load balancer will run a health check and say, we'll constantly ask these things. And here's what a health check is. The network load balancer, the AWS load balancer, will do the following. F5, are you there? F5, are you there? F5, are you there? Are you there? Are you there? And the load balancer is going to say, I'm here. I'm here. I'm here. So, are you there? Yes, I'm here. Are you there? Yes, I'm here. Are you there? Yes, I'm here. That's your health check. That's the way it's supposed to work. Now, the elastic load balancer, network load balancer, sends a message to the thing, the F5 load balancer. Are you there? No response. Are you there? No response. Are you there? No response. Now this virtual machine is removed and 100% of the traffic is now sent on the top load balancer. So that's why we use load balancers for this. Now, if this was a virtual firewall, guess what? We would do the same thing. And we're not going to be using, so we're going to be using the same virtual. So if the same firewall, we would do the same thing. So anytime we need high availability of a virtual machine, we use a load balancer. That's why we're doing it. I hope I answered your question there with regards to that, because that was an exceptionally great question.
And Mike, I want to bring one last question up, but if it's not the appropriate time, just let me know
Okay.
if it's going to be covered later.
How can someone visualize the activity of the load balancer? IO, everything has got a log. Every load balancer has a page that you can go there and you can see the CPU utilization, the memory utilization, the disk performance, the network performance. That's part of your features and functions on the load balancer. So you're just going to go check your load balancer and you'll get the data. Especially if you're using an enterprise-wide load balancer like an F5 load balancer, you're going to have so much data you can use off of the load balancer. A great question there, Io. I wonder if you're one of my students, Io, or my friend, Io. But whatever, Io, we're thrilled to have you here. So let's talk a little bit about making our databases highly available. So what do we mean by high availability database design? We mean that it's going to be there and it's going to work when you want it, when you need it. That's what we mean by high availability database design. How do you design for high availability? Well, there's a rule. There's a military adage, and there's a rule in high availability. 1 is none, 2 is 1, and 3 is greater than 2. So never put your eggs all in one basket, which means if you really want high availability, don't use a single cloud. It's insane to think a single cloud is high availability. But because of network failure, a control plane failure, or a security hack will take down an entire cloud regardless of what you do. So how do you design for high availability? What we're going to tell you here is to host your database in multiple availability zones. And that way, if one data center goes down, hopefully the other data center will go down. Now, I don't want to trust this because we've seen twice this year where AWS has had an outage in one data center and it's affected their global network. So, you really want high availability, use multiple clouds or multiple data centers. But, host your databases if you want high availability. And we're dealing with the exam, host a database in multiple availability zones. And even if I was going to use multiple clouds, I'd probably still use multiple availability zones per cloud. So remember, AWS divides their region, their network into regions, which are big giant arrows, and data centers, which are called availability zones. Use at least 2 availability zones. According to AWS, and they didn't make it this year, but according to AWS, 2 availability zones gives you 99.99% availability, which is about 5 hours of downtime per year. I wouldn't count on that because all your eggs in one basket, too many things to go wrong. But 2 availability nodes, in theory, you could get up to 4 nines availability. No cloud provider has done that this year on a single cloud, but in theory, it could be done. So if you spread half of your stuff to one data center and half of your stuff to another data center, if a data center gets powered off or gets disconnected from the network, and it's a true power failure, meaning both power supplies coming into the company, both power companies, both generators, both backup generators, batteries, and the backup batteries for the data center all were to fail. Like that's what it takes to bring a real data center down due to power, any high availability data center. So if all that stuff fails, it theoretically shouldn't affect another data center. So that's why you're using multiple body zones. Got a power failure in one, the other one's going to be there. Now, with AWS's last power failure, it took down multiple regions. So again, but in theory, that's what's supposed to happen. So let's talk about this. So if you're going to use multiple availability zones, you got to have stuff in 2 places. Now, If you're going to use multiple availability zones, you're going to have a master and you're going to have somebody that serves the master. So by doing this, you're going to have the leader or the workers, whatever terms you want to use. So keep that in the back of your mind. So what we're dealing with here is multi-AZ. It doesn't boost performance, but it provides availability redundancy. Remember, 1 is none, 2 is 1, and 3 is greater than 2. Have no single points of failure, and your systems are going to work. So what happens is multi-AZ, if your main database fails in AZ1, guess what? The database in AZ2 becomes active. And that's what we're talking about. And that's why we're talking about it. We're talking about survivability of the cloud. We're talking about making sure your systems work under any circumstances. So how does it work? You take your data, move it to one database, and it's synchronously, meaning instantly, copied to the database. How is it instantly copied? You got a network between them. You just send your data over the network, and that's why your network matters. No network, you got nothing. Networking is the foundation to the cloud. So kind of keep that in the back of your mind. So what does it architecturally look like? If you're going to do this multi-AZ approach, and I strongly recommend you do multi-AZ. I just recommend if it really matters, do 2 availability zones and 2 different cloud providers. That's high availability. So look here. Let's say we've got our same 3-tier websites. We've got our load balancers fronting our web servers, our load balancers fronting our websites, and then we've got availability zone A, which is our main database. And this is what's doing the work. We've got availability zone B is just failover, so anything happen. So what'll happen is if anything happens to this database over here, this backup database will take over. And that's what we're really trying to talk about. It's that backup database, that survivability. So let's talk about this. What is going to cause your multi-AD database to fail over? Well, if your main database fails, ding, 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 switch is over. The power goes off. Not that you should ever have a power supply in a data center. I haven't seen many power supplies in data centers in 25 years because I've never seen a data center that didn't have redundant power, redundant generators, and redundant batteries. But, there's a first time for anything. But, in these environments, if the data center were to lose its power, everything will switch over. If the network were to be cut off from the data center, it would work. If there's a fire in a data center, it's going to fail over to the other data center. If you put your database under maintenance to patch it or upgrade the OS, guess what? It's going to fail over. So if you initiate a reboot with failover because you want it to go to your new system, that's exactly what's going to happen. So I love this. Got your primary database, it's good. Primary data center is good. Got a problem in the data center, switch it over to the other one. So multi-AZ, definitely never, ever use a single AZ unless you're going to you have a data center, AWS, Azure, and Google. Single AZ in 4 places gives you a 5 nines network. And now you're protected against 3 cloud providers breaking down on your own database. That's the kind of stuff I do. I don't have anybody that's ever going to come to me and say, hey, stick all my eggs in a single basket. I don't have anybody that would ever do that. So there's that. So that's what we're talking about multi-AZ. How could you make it look with multiple things? 2 data centers, 2 cloud providers, but at least, never use a single AZ. Never, ever use a single AZ. At least 2 AZs, and ideally 2 cloud providers. AWS will say that you can get to 4 nines or 99.99% available, which means 5 hours of downtime per year effectively with using 2 AZs. Now, granted, every outage they had this year took out multiple regions or AZs, even though it shouldn't have, but it did. So you can see that nobody got 5 nines availability this year at all with AWS, no matter how many AZs and regions they use, which is the same strategy. We don't like it because you're putting all your eggs in one basket. But never, ever deploy your database in a single AZ, and never, ever deploy anything in a single AZ unless the business doesn't matter to you, or unless you're using multiple cloud providers or using a hybrid cloud or a multi-cloud. So tomorrow we're going to get into some networking stuff, which is going to be my favorite thing in the world. I love networking. So we'll talk about some networking things. Remember, the network is the foundation for everything that we do. It's all on the network. So let's do this. If you've had a good time, please hit the subscribe button if you're not a member, and hit the bell. Please, please, please make sure that you sign up for our How to Get Your First Cloud Architect Job webinar. I want every last one of you cloud hired. Hundreds of people have been here today, and I want you all to get hired. So please do that. If you guys want, we'll run another BGP workshop where I'll talk about the protocol. We can do that very soon. Talk about how it works, talk about BGP performance tuning. I'm always happy to hold a networking workshop, a BGP workshop at the end of the month. And Chris, do we have the registration page set up yet for the CCNA registration?
Yes, I've been sharing it.
Okay,
it's in
great.
the description also.
Okay, in the description, you can sign up for the free Cloud Architect version of the Cisco Certified Network Associate. One of the best certifications for you to get if you're not coming from a networking background. To put it into context, the AWS Advanced Networking is a 200-page book. The CCNA is a 2,000-page book. We will teach you more about networking in that basic introduction to networking that you would get from all 10 of the other networking, the 10 things that are there. So we're going to make sure you're there. There's no one that needs to start at help desk ever. I didn't, and no one needs to. We like to get these basic CCNA things or those big functional things, and we use them as our basic because we don't believe in starting at the bottom and working way you're up. We start you at a good position and we get your way better. I have lots of respect for people in all different careers, but you don't have to start somewhere. You can start at a mid-grade and accelerate your career like a rocket ship. If you start midway through, if you start at the bottom, you got to work yourself for 10 years to get midway through. But if you start midway through, you've got 10 years accelerated. We only live a certain number of lives. So I'd rather you be at 30 where somebody else is at 40. And if you're 40, I want you to be where somebody is at 60. So that's kind of what we do and why we do it. So please join us for the networking thing. Please download your completely free AWS Certified Solution Architect book. Again, Chris, this is all in the description below, right?
Yes, it is.
Okay, so if anybody has any last minute questions for me, I can go for a few minutes, not too long. I want to make sure you all had a good time. In fact, if you had a good time, I'd like you to type two things. First, I want you to type hashtag Cloud Architect, and then I'd like you to type hashtag Cloud Hired. I'd actually like to see that from every one of you so that I know that we're all having a good time. I view Cloud Architects and Cloud Hired as telling me that we're doing a good job keeping you all happy. So please type Cloud Architect and Cloud Hired.
So we have some questions that we weren't able to get to in the previous question session.
Okay.
Do you want to go back to some of those?
Okay, so I want to inform everybody, we are going to stick around and answer some of yesterday's questions, which makes me really happy because I want all of you guys becoming cloud architects and getting cloud hired, and I will do anything I can in my power to help all of you. But I want to let you know that if you're here, that the main part of today is actually completed today, and boot camps last 3 hours. And look, I'll go as long as you want to go, but I want to make sure you're here back tomorrow because I want to know that you're all getting cloud hired and becoming great cloud architects. So if you're tired, if you're exhausted, you don't need to stay. If you'd like to say, God, I'd love having you here. This makes me feel so good to see an audience. I love it. You guys are coming from all over the world, and I absolutely, absolutely love it.
All right, so here we go.
Abigail Marks, as a read peg, could you repeat the cliff notes of a cache and a read replica? Abigail, absolutely. So here I am, the primary database. I am there. Now we've got thousands of people asking questions. So, and that's basically what happens. You would query a database to find out information. What is a queried question? So I'm me. I got to deal with people registering and people asking questions. So here's the thing. I make me as big as I can, and I'm the master database. Now, when these questions come in, I hire 4 people to answer the questions full time. They're my customer service reps. They're called read replicas. So question comes in for me and it goes to one of my team. The CEO can't answer everybody's questions no matter how hard I try. People send us mails to our mail and they're like, "Hi, Mike." And I'm like, "Look, this isn't Mike. This is a team. We're a company." So, and when I call someone and say, "Hey, this is Mike Gibbs," it's Mike Gibbs, but you send an email to a company, you're not going to assume it's Mike Gibbs. You're going to assume it's the company. So, that's so my read replicas are like my staff that answers people's questions. How do I become a cloud architect? What do I need to do? Now, then what if I Chris from my team decided to come up with a frequently asked questions page. He says, "Mike, every day, 100 people ask you these same questions. Mike, in your 3,000 emails, I've noticed that you write the same responses all day." So what do? We come up with a frequently accessed questions section to the website. What is the frequently accessed questions? The cache. So I've got my 4 customer service reps. I've got somebody asking what I see to be the most common question I've seen on LinkedIn. And it is the most dangerous career killing question I've ever seen. And the question is, what certification should I get? Now, if the person said, "I desire to be a cloud architect, I come from this background," you could say, "Okay, get the certification." But when someone just says, "What certification do I get," for example, we don't know. And here's the reason why. What'll happen is when somebody asks that question, we're going to see thousands of people parachuting in. Become a developer. Take this A+ thing, this Net Plus thing, the Security Plus, the CCIE, a developer exposure, etc., etc., etc. They're going to be asking that question. Now, I'm going to answer the question. I am the primary master database. I answer it like this. Please tell me your desired career. Because the right certification can build your portfolio or brand and help you get hired. The wrong certification can help you not get hired. So I write that down now, Abigail. Now, I write this. Now, it's now in my database. So now this question is asked literally 300 times a day on LinkedIn. So I could have my 4 customer service reps, meaning my read replicas, go to LinkedIn and all day and type the answer to that question. I could do that. Or I could basically write it up once and I could say, "Your question is very essential. Please go to this website." That's the cache. So the cache is basically something that stores frequently accessed information. So you're asking me a question, what career should I do? It goes to me. My read replicas, my customer service executives, respond to the question. My customer service executives decide to say, "Hey, wait, I've seen this question 100 times. Let me store this question in a cache," which is basically here's the answer to your question, and send it back to you. So you're no longer answering the questions anymore. So the point is, the read replica is like a customer service rep that answers it, and the cache is like your frequently accessed questions section that basically your customer service reps say, "Go here." So by the time it gets to me, if it was commonly asked, it got asked to the cache, answered by the cache. If it was not, if the cache didn't have the answer stored there, it sends it to the read replica, which does the reading. That's the difference. So Abigail, I hope I explained that. I tried to take it outside of tech, and I tried to use LinkedIn because we were talking about social media the other day, but that's realistically what I'm talking about. Point your main rights to the leader. Your read replicas are like customer service reps that respond, and the cache is basically things that take what your customer service reps have done, store the information for easy access. Great question there, Abigail. Can S be used in real time, like a banking transaction database? Well, here's the thing, Raul. SQS can and will be used in real-time transactions, but the problem is when you use a cache, it adds latency. Now, that latency may or not be tolerated by the application. So if you've got some of these banking transactions that can't tolerate additional latency, then no, you can't use a queue. And what determines whether your application can tolerate this latency or not? The application, your business requirements, your legal requirements. If I was going to make a programmed algorithmic training thing and I need to worry about a nanosecond of a competitive advantage, I wouldn't be in the cloud, I'd be in the data center. So what determines your requirements for any of these things, Raul? The business requirements. So what kind of latency does that application need? What kind of latency can the company have, for example? Can they tolerate a millisecond of latency? Do they need a nanosecond latency? Do they need sub-nanosecond latency? That determines what we use and how we use it. So it's always going to be driven by the business. So yes, it could be used in some applications, and no, in other applications, it would actually destroy it. So it's a matter of knowing the business requirements, and that's why the communication skills are so important, because we've got to find exactly what the requirements are. Tejas Patel, you can't use load balancers for databases, so that kind of removed that, and that's why we're using read replicas and caching. Mohammed Abras, can you use traffic policing and traffic shaping? Oh, that's the thing. So Mohammed, I'm assuming you're a networking person, where you're talking about priority queuing or weighted fair queuing. Here's the thing on the cloud. We lose all control of the network. So we have no ability to do anything in the cloud like this. So, I mean, we can load share via BGP, for example, by linking one subnet on one link and another subnet on another link. Absolutely, we could do that. But we have no networking control. So we lose all the security things like layer 2 access lists. We can't do 802.1x, for example, good security. We can't run private VLANs. We can't run QoS. We can't do any of it on the cloud. So effectively on the cloud, we lose so much of our good networking capabilities. And that's a lot of the reasons where if you really need high performance, you're not doing it in the cloud, you're doing it in the data center. But in most cases, the cloud is good enough. The agility of the cloud, the cost effectiveness, but the transformation approach, because it's so simple and agile, is enough to tolerate the lower performance of the cloud compared to the data center. So no, all that cool traffic shaping, your layer 2 access list, 802.1x, private VLANs, QoS, we can do it on the way there, but that's pretty much it. We lose all control on the cloud. Excellent question, Mohammed. And now you know why people like me are still building hybrid clouds and still building data centers, because the customers demand it. Because when it really counts, you can't do it on the cloud. You can do 80% of your stuff on the cloud, but certain things are still better in the data center. If I was going to build a programmed algorithmic trading system, and I wanted the system to process 2 billion trades a day, and I wanted to buy that stock based upon news in the algorithm and nanosecond before somebody else, and sell it in nanosecond before somebody else, and nanoseconds can mean millions of dollars a day to organizations like this, I can't tolerate 3 milliseconds on a direct connection to the cloud. I need to do it locally. So it's a matter of, we don't have the networking capabilities, or a lot of it. So we have to be very careful with what we do and what we put on the cloud, because you're right, you can't traffic shape, you can't control, you can't do any of that. Great question, Mohammed. You've got to be a networking person asking these questions, because I have a feeling you've been doing a lot of architecture. I'm not sure what multi-CSP means. So I don't know how to answer that.
Cloud service provider, maybe multi-cloud provider.
Okay, so Rule, I'll tell you, if you ever want to be an architect, I strongly recommend you not use abbreviations or acronyms. They will not be accepted by your CEOs or the CTOs or your customers. So while they're great in engineering and architecture, we can't use them. We have to be explicitly clear. And here's the reason why. It's already challenging enough. We're coming from all over the world. We need to make things as simple as possible. So if you're assuming multiple cloud providers, do you need some networking and security component? Yes, absolutely. What are you going to do? You're going to have your data center. You're going to connect your data center to the cloud, which is 2 additional data centers. You're going to firewall off each cloud provider from each other. You're going to run access control lists from each other. You're going to filter your routing information. Yeah, there's a lot of security that goes there. Incredible security, because if AWS is hacked, you don't want that going to Azure. And if Azure is hacked, you don't want it going to your data center AWS. And believe it or not, these things are going to happen. Azure was hacked this year. We've had a lot of mysterious cloud outages this year, big ones, big mysterious outages that there's no plausible explanation for. So you definitely have to use security. Now, we did cover a multi-cloud architecture. Chris from my team can do it. And we covered what you need to do with the routers, what you need to do with the switches, what you need to do with BGP, what you need to do on the security end. And Chris, you can provide the link to that. We covered it in real depth. It is an excellent question. Chris?
Yeah, I have no idea what happened there.
Not sure, but I'm happy to see it. Were there others, Chris?
Do you see it on the screen?
No. It's weird. I actually see something on, okay, now I do. Jacuzzi, how does SQS handle messages? Message comes in, message comes out, message comes in, message comes out. So Jacuzzi, I know you and I know you well. There might be something more to the question that I don't understand. Basically, you got a box. Imagine a box. Box can hold 1 million messages. Send 1 million messages in, got room to take one out, got room to take the next one out, got room to the next one out. Kind of like an airplane. When you get in line on an airplane, same thing. You all get in a queue to get on the plane. First person goes, then the next person moves up the line. The next person moves. That's how SQS does it the same way. And Jacuzzi, if that's in question, in one of our next big architectures in class, we'll make sure we do some queuing work because I think it's a great point. But I want to make sure we get you all the answers you need. So in the next Tuesday or Friday class, we'll do it. Obviously, we don't have the Friday class this week, but we definitely have it next week. So no response. Reroute your traffic. Remember, you've got a network and you've got a routing table, and there's already network layer reachability to every subnet that you actually have, assuming you set up your routing right. So all you have to do is cut off one link, and you already have network layer reachability in your routing table, so there's really nothing to do. But that's why you're setting up your BGP, and you're setting up dynamic routing, and you're not doing static routing, et cetera, when you're dealing with these things. It's a good question, though. And when we do the CCNA, we'll cover a little of that or a lot more of that because it's really important stuff.
So apparently at some point you asked for people to type cloud architect.
Yeah, well, you know I love the word cloud architect.
Yeah. Okay, there we go.
IO. It's a different IO. It's always good to see you, IO. We actually have 4 IOs in our program. I know it's a very common Nigerian name, and we're always thrilled to see you. So is a read replica the functionality of the database system you're using? Pretty much most of them have read replicas. So, you know, MySQL has read replicas, Postgres has their thing. So yeah, pretty much the same thing. There's all relational databases effectively have a read replica, but not all of them are different. MariaDB does it slightly differently, but for the most part, all relational databases have read replicas, whether it be Oracle, MySQL, etc. Great question. That's pretty much standard relational database scaling. Tosin, please clarify again which databases can be partitioned and why. Technically, Tosin, you can partition a relational database to help it scale. Most of the database architects that I've spoken to said don't even touch that ever, but you can partition a relational database. It's not my world. I'm not a database architect. When database architects with 20 years experience say, Mike, I don't touch this, I don't like this, I listen. So NoSQL databases such as DynamoDB, Apache Cassandra, Google Cloud Bigtable, MongoDB, I think Microsoft calls theirs Cosmos. They're all partitioned because they're all NoSQL databases. Why are you doing it? So Tosin, with relational databases, we basically have read replicas. With NoSQL databases, we don't use read replicas. So what do? We just chop the database into multiple partitions, and each partition becomes like its new database. And that's how we scale them. So with relational databases, I hire my helpers, my read replicas that help work me. In NoSQL databases toasting, what we do is basically just create 4 different databases or 5 different databases on big servers. And that's what a partition is. It basically creates almost a new database, and it's like a routing function that makes sure your information is connected, is routed to the right partition. I'm just saying, if you can't use load balancers for databases, then wouldn't it be cumbersome for some apps to maintain DNS names with multiple read replicas? It's not at all. This is just the way database architecture is done. And remember, you're going to be using those additional DNS names intelligently to point your read device to. So it's not a problem. It's not cumbersome, and that's the only way you can do it. So it might not be the most elegant solution, but it's the only solution. And SQS seems to be a message queue just like RabbitMQ. It's identical to RabbitMQ, other than it's an Amazon proprietary one. Is it also...
sorry. I thought it's...
Okay. I don't know what you mean by KV cache. Again, we're dealing with abbreviations. I don't understand them. Chris, if you want to go to the next one. Ronald Nazo, how do you share the load on read replicas? Well, if I said, ask Abigail these questions, you'd know to ask Abigail. If I said, ask Brandon Bowman these questions, you'd know to ask Brandon Bowman. When you set up your application dashboards, you point them to your read replicas. So you manually tell them where to go to. The way you could go to the website, www.cindythecat.com. One day I'm going to make a website, my beautiful cat Cindy. I'm going to call it cindythecat.com. Please don't register that name. I need to get registered today for my kitten. So if I told you all to go to cindythecat.com to see my cat chasing little aluminum foil balls, and my cat chasing then I hold the fishing rod and I hold feathers on the fishing rod and she chases it, you'd go to Cindy the Cat. Now, if I told you to go to cindythecat.com, you'd see the Cindy things. Now, if I told you to go to sunnythecat.com, you'd see Sunny the Cat's pictures and videos. Sunny the Cat is different than Cindy the Cat. Sunny the Cat is Chris's cat. So if I was going to set up for rare replicas, I would say you go to sunnythecat.com, you go to cindythecat.com, you go to Abigail's cutest cat in the world.com, et cetera, and I point you to those things. So that's how you do it. You know, I don't know why, but somehow I'm on a cat thing because Mike, can you create a design section where you explain real-life end-to-end system design on AWS? We're going to do one next week. It's the Cloud Architect Experience webinar. It is your chance to be a real cloud architect for the day. Chris, could you please provide the link to that so people can register? That's the thing I've been asking you to register for the whole time. Yes.
Well, you've been asking them to register for tomorrow's webinar, which is
I've been asking people to register for 1,001 different kind of webinars today. So.
Yeah.
Free books, free CCNA courses, free webinars.
Free.
Yeah, we're trying to make January your month where we give you guys just so much to really help you on your cloud architect careers or solution architect careers or enterprise architect careers or anything.
I felt like that roadside wacky wavy arm flailing inflatable tube man trying to get people to come get the book.
Pretty much what I've been here. Take this free one. YH, please take this free architecture seminar. I promise you'll learn more in 3 hours than you would by 6 months of doing multiple AWS certifications. We're going to do real architecture, real high availability, real high security, end to end. We'll probably do multiple clouds because I would never do a single cloud either. So we'll show you what the real life cloud architect is.
Or more appropriately, it'd be like Oprah. You get a car, you get a car, you get a car.
Exactly. That's exactly what I'm trying to do this month for you. I'm trying to share as much as I can of my 25 years experience free this month to help you guys all get started. So yes, we'll do that. YH, please register. Chris, you want to bring in the next one?
Well, this is a follow-up to a question from earlier from Ronaldo, but I don't remember it, but you may be able to connect it back.
Yes, if you configure your load manually, you are not going to get 100% perfect load sharing. The only way to get 100% perfect load sharing is to use a load balancer. And that's not even going to be perfect either, because some of them are going to maintain traffic flows, and certain traffic flows are going to be less than others. So you're never going to get exact load sharing. The only time you would ever get exact load sharing is if you're using basically an inverse multiplexing environment, where you're basically taking two things and you're saying photon 1 goes over this fiber optic thing, photon 2 goes over this fiber optic cable, photon 3 goes over this fiber optic cable, and photon 4. Basically, you'd bundle them together in a link aggregation group or ether channel. But no, there's no way to get exact perfect load sharing in anything. So yes, it's not going to be equal. Even if you use a load balancer, it wouldn't be equal, because the network load balancer keeps the flows on certain servers. So guess what? That might not be equal either. Man over cloud, AWS allows 4 read replicas as a rule, but certain databases like Aurora can go 15 read replicas deep. So now, because you can do 4 read replicas, what they also enable you to do instead of this. So you saw my read replicas, my super amazing cloud architects that were helping you. Now, what potentially could is I could have, my real main read replicas, my Brandon Bowman, my Abigail Marks, my Eva Doikia, who else? Jazz, and I know I'm missing someone, so apologies. Now I could have them, basically, they could then manage another set of read replicas that would be more junior students. So basically I could have my read replicas, and then I could have copies of those read replicas, and I think I can stack them 4 deep by doing that. But remember, the more read replicas you create, so if you create layer after layer after layer after layer, each layer creates a new layer of latency. And by doing that, again, you punch yourself in the same problem. So you're looking for the maximum speed and performance. In order to do that, what you're looking for is as follows. 4 read replicas, and if you need to go deeper than that, you can, but you're probably going to go to caching long before you're going to go to creating second-tier read replicas. So imagine you've got your write, your reads, and then you can stack your read replicas, all pulling off of the read replicas. So you could do that if you needed to for huge data environments. It's a good question. Ben Orpheus, cloud hired. I love that name. Tom Orpheus. Hey, Ben, watch out. Mike will get you cloud hired. I sure would like to. Now, I know you're in the Netherlands, but you got a really great last name. And if your last name means you speak the same language like me, it's nice to see you here. Yasu. Millicent, such a great boot camp. Thank you so much, Millicent. Chow Farm, friends, don't forget to save your time for tomorrow's class. No, come back tomorrow. Let's learn much more solution architecture and cloud architecture. Ernestine, you're awesome. Mike, love your energy. Thank you for using it. Thank you so much. I'm so grateful you were here. Dan Shader, another great session. Need to catch up on yesterday's stream. It's here. It's on YouTube. Like it, enjoy it, subscribe, tell your friends. We want to help as many people as we can. Deland, yes, the network is the computer. Well, that's funny. Sun Microsystems believe that. And why did Sun Microsystems believe that? They made Linux machines. But you know, Declan, what those Linux machines never worked without? The routers and switches from Cisco. So the network is the routers and switches and the cabling. The computer people want to pretend that stuff doesn't work. But as you've seen, Facebook pretended it didn't work. They had a BGP misconfigure and had an $8 billion outage. Guess what? The network is not sitting on a server. It's sitting on a router. So there's that. If I want to reach Dean in UK or Wales, I can't reach him without a network. So the network is everything. Jeannie, thank you so much. Eva Doikia, I had an awesome time too. Thank you so much. Felix, great outing today. Thank you, Mike and Chris and the Go Cloud Architects family. Thank you. Mark, so nice to see you. Thank you. Pierre, thank you, Mike and Chris. Pierre, thank you for being here. I'm so appreciative of you being here. Raphael, Eferistopatopoli. Oh, that means thank you very much. Parakolo. And Mike and the rest of the gang, Eferistume. Ronald Nazo. Is there a service like a load balancer to multi? Ronald, I'm not sure what you mean. If you're talking about how do you connect to multi-clouds, you're going to use BGP. Routing is how you load share on the network. So I'm not completely sure I understand the question, so I hope I answered your question.
This is a good one.
Matt, is a cloud architect would be customer facing? Yes. So do you need an approximate given a cost of the services? No. No. There's a sales rep that goes with you that has all the numbers and the pricing. You're going to have somebody on your team that's going to do the costing. They're typically an inside sales rep or an inside sales engineer. They are much lower paid than the architects that are doing this work. As an architect, you are too expensive to be wasting your time doing these things. It's important work to figure out the cost. But a good architect can earn $300,000, $400,000, $500,000 a year, and I can pay somebody $60,000 a year to look up the cost savings. So I don't want to dedicate my $150 an hour resource to doing this, when I can dedicate a $20 an hour resource to doing this. So, we're not going to be doing that. Eva Doika, what a great start for the new year. That was my plan, Eva Doika. Free ebooks, free Cisco, free AWS. That's what I would want if I was younger. Io, thanks, Mikey. Actually, interestingly enough, I really appreciate that. I have a lot of Ethiopian friends, and they all call me Maki or Mikey. And guess what? I've got a tremendous number of people that are Greek that like that the same. So I like that. Io, thank you for thanking Chris. Chris is every bit 50% of the company in every way. Leo, thank you so much for sharing your knowledge. Leo is Go Cloud Architect. We just hired him, and he's working at Go Cloud Architects now. Congratulations, Leo. Patrick Luna, so thankful that you're here. Leo, cloud hired. Yes, you are cloud hired. Marla, thank you for all you do. Marla is one of my amazing disciples. She's a phenomenal cloud architect in every way. Same for Jazz. Always great to see you. Jazz, thank you. And thank you for all your help last night, helping me do some research for some statistics. Kenny, thanks so much. I look forward to tomorrow, and I look forward to seeing you. Tom, honestly, it's always great. And if your brother Ben is here, thrilled that he's here. Abigail, please tune in tomorrow. Abigail is another one of my, is fantastic. Mr. Binary, as I like to call you, 0101, thank you so much. Dragonfly, thank you. I just want to help everybody have a better life. Cafe Memories, thank you, Mike, and everyone in the background. Yes, thank you, everyone that's been helping me. Chris and Brandon and Abigail and Eva Doikia and many others. Leo, thank you so much. Chris does so much stuff in the background. You guys have no idea. And Tosin, thank you so much. Raul, thanks, Mike and Chris. AWS M session, thank you so much. Oh, awesome session. We share that it's the best boot camp you ever had. Thank you, Mike. That's our goal. I want every one of you to get that real heavy duty, real training experience, the real life career. Charles Simpson, thanks, Mike and Chris and the rest of the team. This is awesome. I'll see you tomorrow. I'm excited to see you tomorrow. Raghavu, thank you so much, which is informative. We are so happy to help. Hand of God, you always have the most kind things to say. I think if I remember, you were Greek too. You wish us all the greatness, peace, and positive energy this year. Thank you so much. Matt Evercloud, thanks. You enjoyed it today. I'm always thrilled to see you, Matt Evercloud. I know we see you a lot. CEO Trell, wonderful, amazing student. Thanks, Mike. We're happy to see you. And Tosin, thank you so much. And thank you for thanking the Blue Wrench people, my people that are here and helping you. Thank you so much as well. Come back tomorrow. Yes, Eva Doikia. CEO Trell, congrats, Leo. Thank you. Congrats, Marla. Thank you, Marla. See you tomorrow. Olubodi. I'm thrilled. Apologies if I mispronounce your Nigerian name. I'm just thrilled to have you here. And congratulations, Leo. Wonderful. Thank you, Chris Johnson and everyone else. That's fantastic. Tejas Patel, your energy and enthusiasm. Thank you. Chintan, every time you call me Guruji, it brings tears to my eyes. And when you sent me that first mention on Guruji Day, till now, Chintan, you always amaze me. Carl Jr., thanks so much. Robert Welch, you're welcome. Rosie Georgietta, thank you so much. And Chikozi, we're thrilled to have you here. And Leo, saying thank you to all. That's great. Abigail Marks, Abigail's around. She does so much. She helped build our family here, and I'm grateful for that. Amazing explanations. Thank you so much. Thank you so much, Leonardo. And Mario Millen, we're always so happy to see you. In Bethesda Mill, we have somebody with your last name that recently got hired by AWS too. And Richard Belovox, thank you so much. And CEO Trell, you're continuing to post on LinkedIn, and people are asking about the program, so you recommend they join. Thank you. So here's the thing with LinkedIn. Once you start posting, you start building a name and a brand. And when you have that brand, the world comes and searches for you. Jazz is an amazing, amazing individual. He does so much. And thanks so much. VNHD, great day. Thank you so much. Another amazing individual, another great student. IO, it's always good to see you. I'm not sure which one of the IOs you are because I know so many IOs and I love every last one of them. So I'm so happy to see you. And Dasha, thank you so much as well. We're thrilled to have you here. There you go. Thank you for recognizing Chris. Thank you so much, Raphael.
Uh-oh. We might have some psychic people.
Mike, since you have hired new, very skilled people team, are you planning to update your course? Well, I will say that we've completely refilmed our old course. Half of the content was already updated. The remaining content will be placed there on by the end of the month. When the new content is updated on the course, there will be a price increase on the course because we put a lot of time, effort, and money into creating new content. So this month is probably the best opportunity to join our program for that reason. But we're bringing in more people. We have a reason. We have growth. We were featured in 10 magazines as subject matter experts this month. We've already done 10 more interviews that'll be done next month by major magazines because they love what we do. Our book was featured in 407 press outlets yesterday. And I literally get hundreds of people calling me each day saying, I want to be part of the program. And when they call me, I cherry pick them. When they sign up, people just go and they become great students and they do well anyway. But the point is, it's just, we are always improving our products every day. How do we work with our products, YH? Very simply. Well, the rest of the world is focusing on passing an exam. What we do is we ask CEOs, we ask hiring managers, and we ask the world's best test recruiters, what do you want in the perfect employee? And I have these conversations constantly. And we always adapt our course to what the hiring managers tell us they want to hire. Because the best way to produce a product that sells is ask your customers what they want. So a third of what we do is figuring out what people in the industry want from us so we can make sure that our product is always the first to get hired. So we constantly update our training and we give all the updates completely free to the people that do it. Dasha, so interesting, not like other training that made me sleep. Well, the first time I ever bought a PowerPoint slide with voiceover, I was able to survive 3 minutes before I had to dump it, and I didn't want anybody to do that, so that's why I try to make these live interaction boot camps. Sanchin, thanks so much for this session. So many analogies and example, easy to understand. Thanks, Mike and Chris. Thank you. That's the whole goal. We like to demystify the cloud. I love the cloud, and AWS is an amazing cloud provider. They're really great, but their marketing team, in order to make 20 to 50-year-old data center technologies sound cool, they have created the most ridiculous names that I've ever seen. And in the process of creating the ridiculous names, they have confused everyone. So if I can unconfuse you by getting back to the main things, when you work at Azure, Google, Oracle, the data center, I want you all employed. And I want you to be paid double everybody else because you have the right skills. So executives don't think in terms of acronyms. Executives don't think in terms of DynamoDB. Executives think in terms of, I need a database and I need it to scale so I can have access to the best information to make the best business decision. That's all they care about. How do I improve their business? And that's what we do as architects. So thank you for noticing. Daniel, I'm hoping to get better with Nigerian names. I have over 100 amazing Nigerian students, over 75 amazing Cameroonian students. Students in Ethiopia, Eritrea, Benin, Gabon, Uganda, Somalia, Djibouti, South Africa, Zimbabwe, Tanzania, Morocco, all over the world. And I try to do the best with names, but I struggle a little bit. But, I really try hard. And I respect people that are working so hard all over the world. So we've got a wonderful number of Nigerian students, some incredibly motivated people that accomplish such incredible things. We see incredible people in India, incredible people in Pakistan, incredible people all over Africa, America, Europe, the Middle East, Asia. And I'm trying to get better with Nigerian names. I actually have 49 students volunteering in Cameroon right now to do this. We'll probably stop in Nigeria next. We've got so many students, so many parts of our family that are there. So thank you so much. I'm trying to get better every day. Kenya Carl. Kenya's what a special person. She's one of our students. Michael, you are helping and encouraging so many people. I hate to sound like a broken record, but it should be repeated. Thank you so much, Kenya. Robert Welch, love this. We did a LinkedIn profile update for Robert Welch, and 3 recruiters reached out to him on the same day. So that's the reason we do so much brand building for our students. We don't want our students having to apply for jobs. We want people coming to them for jobs, better jobs, higher paying jobs. So build your brand. I'm glad it's been working out, Robert. You're not the only person that got an instant interview after that day. So I think we probably answered the questions that we had for the day. This is Michael Gibbs. I'm the founder and CEO of Go Cloud Careers. If you're not a subscriber, please subscribe and hit the bell notification. Please make sure you register for the free How to Get Your First Cloud Job webinar tomorrow. It's going to be a great time. I'm going to teach you everything you need to know to get hired. I'm going to teach you how I went from medicine to the lead architect at the world's largest internet service provider in 6 months, and how no matter what your background is, you can be cloud hired by leveraging your experience. And I don't care if your experience was customer service, accounting, law, or nursing. It's applicable, and I'll show you how it's applicable by knowing the mind of the hiring manager. Then we'll tell you exactly what hiring managers want, because if you are the perfect product, the consumer will always buy you. And consumers like me will pay more for a car that we like than a car we don't like, or a computer we like. So we'll teach you how to be the hiring manager's dream hire. Then we'll teach you what your portfolio needs to look like, your certifications and resume. Then we'll teach you how to skip HR and get hired directly by the hiring manager, and you're going to be good to go. So those are the recommendations that we have for you. So I'd like to thank you for your time. Thank you for being here. I've really enjoyed spending the time with you. I try to do this to help the cloud architect community, the solution architect community. Go out there, get yourselves cloud hired. Let's get you cloud certified. Let's teach you cloud architecture. Let's teach you a little bit about networking, and go out there and get cloud hired. Let's end the day with one more cloud architect and one more cloud hired from everybody. So I know we had a great time. Thank you all, and I look forward to seeing you tomorrow. So one more cloud architect and one more cloud hired, everybody. Fantastic. I know everybody's here this way. Fantastic. I'm loving this. See people from all over the world. I'm looking at names all over the world. I'm loving this. Just look at some of these names and you can see where people are from. What a wonderful experience to get so many people in a community together. I'm honestly honored and I'm humbled to have all of you here, and I'm just so grateful. So let's make sure we have the best day tomorrow. Let's build the best cloud architect training we can, and let's do everything we can to help you all get cloud hired. Thank you so much. I look forward to seeing you all tomorrow. Have a wonderful night, everybody. I can't wait to see you tomorrow. Mr. Gee, I like that.